Welcome students. In this class we will be performing some review of topics that we have studied previously. So foremost I would like to start off with some basic application of the identities that we have come across. Now suppose, imagine that you are being given as something of this fashion: a times sine of bx positive c. Now this is a famous identity which is of the form sine of a positive b, right? We have come across this identity. We know this. This is a well-known formula. So I will be applying this. Now this can be rewritten as a times of sine of bx times cos c positive cos bx times sine c. Now an observation you need to take into account is the fact that there is a presence of a variable x. So this is the unknown variable, and the requirement is to find this particular unknown. So I can clearly distribute the value of a inside and rewrite this as a times cos of c times sine bx positive a times of sine c times cos bx. So I've got a quantity. Now what I wish to do is the variable which is present here, I don't want to touch this variable, but what I will do is I will take this quantity a times cos of c to be equal to some m, and a times sine of c is equal to some n. It's up to you, whichever value you want to take it as m, you take it. There is no problem at all in that. Now if you were to consider m squared positive n squared, then this is going to be a times cos of c raised to the power of 2 positive b times this is actually a times sine c raised to the power of 2, which is equal to a squared times cos squared c positive a squared times sine squared c. If I were to take a squared out, this is going to give me a squared of cos squared c positive sine squared c. Now what is sine squared c positive cos squared c? That's going to be 1. So this is nothing but a squared of 1. So this would mean I now have a relationship in this fashion: m squared positive n squared is equal to a squared. Now this will come in handy in solving many related questions. Now from this we can have a few of the relationships being expressed here. Now if you remember, we started off with this particular formula, and then we assumed that a times cos c is equal to m and a times sine c is equal to n. So therefore what I can do is also now we can write a times sine of bx positive c to be as, in place of a times cos c, I'm going to substitute m times sine bx positive. In place of a times sine c, I'm going to substitute n times cos bx. Right? So you got a formula in this fashion, where if they're asking you to find the value of a, you can clearly write this, where a squared is equal to m squared positive n squared, and just in case if they want to find the value of cos c, what exactly is cos c or what exactly is sine c, then from here you can clearly see that from here, therefore cos of c is m over capital A. Now this is achieved. Along with that we got sine c. So sine c is equal to n over capital A. So you got two expressions from which the unknowns, no matter whatever they are asking, can easily be obtained. So this is a very important deduction that we have just achieved. Let's do this question, students. We've been given this question: x plus 4 times root of 3 sine 5x positive 4 times cos of 5x in the form of a times sine of bx positive c, right? So solution. So let me start off with this statement. We know that a times sine of bx positive c is equal to, I'm going to be using this expansion which we have got. So this is equal to m times sine bx positive n times cos bx. Now comparing the, imagine, let me take this as 2, comparing the right hand side of 2 with 4 times root of 3 sine 5x positive 4 times cos 5x, we observe that. So what do we observe? You can clearly see that m is equal to 4 times the root of 3 and bx is equal to 5x and n is equal to 4, right? Now we have to obtain the value for c. So how are we going to obtain the value for c? Now let's use this formula. Cos c is equal to m over a. Okay, and also this also implies a squared. We need to get the value of a, right? So a squared is equal to m squared positive n squared. Let's finish this off. So substituting 4 times the root of 3 raised to the power of 2 positive 4 raised to the power of 2, what do we get? This is going to be 16 times 3 positive 16, which is equal to, this is going to be 16 of 3 positive 1, which is nothing but 64. So a squared is equal to 64, therefore a is equal to 8. So we got the value for 8, and now cos of c is equal to m divided by a, right? We can use that. But what is my m? My m is 4 times root of 3 divided by 8, which is nothing but cos c is equal to root of 3 divided by 2, and sine of c is n over a. My n is going to be 4 divided by a is 8, which is nothing but 1 over 2. So we got cos c, and I should say we got cos c and we have got sin c. Now let us find out the value for c. Now we start with taking the modulus. So this is going to be equal to root of 3 divided by 2, which would mean my value of c should be equal to 30 degrees, because cos 30 would give me root 3 over 2. So c is 30 degrees, which means the value of c is pi divided by 6. Now it is also imperative to note that both cos c and sin c are producing a positive value, which means it's only possible that they are present in the first quadrant. In first quadrant we are going to be utilizing alpha, in the second quadrant pi negative alpha, in the third pi positive alpha, over here it's 2 pi negative alpha. So clearly this is what we are looking for, right? C is equal to pi over 6, because of the fact that both these values are positive. Cosine is positive, sine is positive. So therefore we have got c, we have got all the requirement. So this means 4 times root of 3 sine 5x positive 4 times cos 5x, which has been equated with a times sine of bx positive c, is going to be equal to, my value of a is 8, nice, times sine of my bx is found to be as 5x, positive, my angle c is going to be pi over 6. So this is a beautiful solution, students, and we can move on to the next question. Students, let's do this question. We have asked to be finding the value of x. So the question is find the value of x such that we have a trigonometric equation. So that is going to be, we are given that sine x times sine of 2x positive cos x times cos of 2x is equal to root of 3 over 2. Right? We expected to get the value of x. Now this is very similar to, I'm starting the solution here. On observation, the left hand side is similar to cos, right? Because two signs are coming, so it's going to be cos, and you got a positive sign, cos of a negative b, right, which is nothing but cos a cos b followed by a positive sign and sin a sin b. The only thing is that it starts with sin a sin b instead of cos a cos b, but still a positive b is equal to b positive a. So we would use this formula. So this would mean we can rewrite sin x times sin 2x positive cos x times cos 2x as cos of a minus b, right? A and b. So it's going to be x minus 2x. So this means if I were to take this as 1 can be rewritten as cos of x negative 2x is equal to root of 3 divided by 2. What is this? This is nothing but cos of negative x is equal to root of 3 divided by 2, which means cos is an even function. So cos of negative x is going to give us cos x, which is equal to root of 3 over 2. Now if I were to take the modulus, I can rewrite this to be as cos alpha, and over here it's going to be cos x. So cos x is equal to cos alpha, where alpha is equal to, this is going to be 30 degrees. So pi over 6. Now go to the quadrant. Pi over 6 is going to be over here, right? Cos is positive. So cos is positive in the first quadrant and in the last quadrant. Yeah, that would mean the fourth quadrant. So over here and over here. So two positive values are there. Now this is actually not specifying any interval. So we have to get the general solution. Now I mentioned to you that cos x is equal to cos alpha, then this would mean the value of x is going to be alpha plus or minus 2 times n pi, right? In this case I'm taking plus. The reason is we got the value of alpha as a positive value. Now there is one important thing you got to know. Now before getting the general solution, you will have to extract those other values, because we have got just pi over 6 for this point, but there is another value for this. So this value is obtained by taking 2 times pi negative alpha, and then we will substitute in the general solution, right? So this is for the general solution, but this is for the extracting the principal solution. So this is equal to 2 times pi, my alpha is pi over 6, which is nothing but 12 pi negative pi divided by 6, which is equal to 11 pi over 6. So therefore the general solution, if you were to start with, then we can have the solution to be as this, right? Alpha positive 2n pi, that could be the solution. So pi over 6 positive 2 times n times pi, where n takes the value, right, set of all integers. N is present in the set of all integers. Now on the other hand, if you were to take 11 pi over 6, then this would also produce me the required value. So 11 pi over 6 plus 2n pi, right? So either you take this, or depending upon what is required. So that would be my solution for x. So this is the value for x. Students, we got an interesting question here. We have been given sin x positive sin 3x is equal to cos x. We are expected to find the value of x present in the interval 0, 2 pi, right? So that is what is required. Now this is similar to, we will be using this all important formula. What is that? Sin A positive sin B is equal to 2 times of sin of A positive B divided by 2 times cos of A minus B divided by 2. I have given you this formula. Please see the video on the complete list of formulae for trigonometry. So using this, if I were to take this as 1, therefore 1 can be rewritten as 2 times of sin of x positive 3 times x divided by 2 times cos of x negative 3 times x divided by 2 is equal to, on the right side I've got cos x. Now if I were to simplify this, this is going to be 2 times of sin of x added with 3x will give me 4x divided by 2 times cos of negative 2x divided by 2 is equal to cos x. Now clearly 2 can cancel 4, giving me 2. So this is going to be 2 times sin of 2x. Now 2 can be cancelled, giving me cos of negative x is equal to cos x. So let me use this part of the page. So this is going to be 2 times sin 2x, cos of negative x is going to give me cos x, which is equal to cos x, because of the fact cos is an even function. Now let me push this cos to the left side. So I would now have 2 times sin 2x times cos x negative cos x is equal to 0. Let me take this cos x out. So that would mean I now have cos x of 2 times sin 2x negative 1 is equal to 0. Now from here I can rewrite this as, this would mean either cos x is equal to 0 or 2 times sin 2x negative 1 is equal to 0. From here I can rewrite sin 2x is equal to 1 over 2. And this is a beautiful equation that we have got, 1 and 2. Now let me just consider cos x is equal to 0. Consider cos x is equal to 0. Now if you were to draw the graph of cos x, when x is equal to 0, cos x it's 1. So it's going to flow like this, right? Now at pi over 2, cos 90 hits 0. So this is pi over 2 here. And this is going to be pi. So cos pi hits here negative 1. This is going to be negative 1. And this is positive 1 there. And then it rises up. And then it would hit 2 pi over here. Right? So this is 2 pi. And then it flows down. Now we have been given x to be contained between 0 and 2 pi. So if I were to write the solution, there is a point here, one point of intersection, cos x is equal to 0, there is one point here, there is another point, 2 points, and we can't push there. So let me just start. If this is a actually just a small correction. This is half open, right? This is closed and open. That is the interval that is being given. Now, in case if it is completely open, let me just assume that now we will be considering this to be as half closed and half open. So let me just make that slight alteration. So this is going to be open and this is going to be closed. In other words, we are actually looking for points from 0 to 2 pi. So that means 2 pi is basically left out. Of course, because if we were to look into the graph of cos x is equal to 0, cos x hits 0 at this point, pi over 2, and again it hits 0 at 3 pi over 2. But we are not going to take 2 pi because of the fact the interval is open, half open, right? So it is because of the interval we would avoid the point 2 pi. So if you were to consider all values of x for which cos x is equal to 0, now clearly you can see that this means x will be equal to pi over 2 and 3 pi over 2. So these are the two values that are good for x given the equation cos x is equal to 0. Now let us work for sine 2x is equal to 1 over 2. This is what we've been given, and x is contained in 0 comma 2 pi. So this is closed and this is open. Now if I were to take, let theta be equal to 2x. So I will take that assumption. Now let me just put this, and I'm not going to apply it as of now. Now what I wish to do in the interval is I'm going to multiply by 2. So this would mean 2x is the element of 0 comma 4 pi. So this is what I've got here. Now I'm going to apply theta is equal to 2x. Now if I were to take theta to be equal to 2x, then if I were to take this as 3, so 3 can be rewritten as sine theta is equal to 1 over 2. Now let me draw the graph of sine theta. So if you were to draw the graph of sine theta, it would be something of this fashion, right? It's a waveform. It goes. So this is 0, and probably we need a bigger graph. So at pi over 2, sine will hit the point 1. At pi it's a 0, and then at 2 pi I think we need to have a bigger graph so that you will be in a better position to visualize it. So let me try to draw the graph over here. So I have this, it goes on, it goes on, it goes on, it goes on. So this is long enough graph. Now sine theta is equal to 1 over 2. Now before that, let me just plot the point. 0, this is pi, this is 2 pi, this is 3 pi, and this is going to be 4 pi. So the point is over here. Now if I were to draw 1 over 2, let me draw 1 over 2. So this is going to be the graph. Now if you were to check the points of intersection, now that will give us the number of solutions, right? So first I want to decide on the number of solutions. So number of solutions, that's going to be our first priority. When sine theta is equal to 1 over 2, okay, that's the graph that we are looking for, 1 over 2. Now there is a point of intersection over here, there is a point of intersection over here, that's a point of intersection over here, and there is a point of intersection over here. So we got 4 points. We can't take this point because it is open, right? So 4 solutions are there. We need to cater to 4 solutions. Now, okay, that's received. So let me go to the quadrant and locate those solutions. Now clearly, if you were to see here, sine 30 gives us 1 over 2. So theta is pi over 6. So we need to extract 4 values. Now going to the quadrant, sine is positive in the first quadrant and sine is positive in the second quadrant. So pi over 6 should be over here. It is over here, right? Pi over 6 over here for the first value. Now we know that this quadrant receives all alpha. This quadrant receives pi negative alpha, right? Now the important part here is that we need to extract those values from the general solution. So clearly I mentioned to you, if some sine theta is equal to some sine alpha, then the value of theta is equal to, let me give you that value, n times pi plus followed by negative 1 raised to the power of n times alpha. So this will give us in general all the solutions. But taking alpha, in this case when I say alpha, we are talking about this value, right? Alpha is equal to 30 degree produces this. So probably I can state here instead of this is okay, but this indirectly means if I were to write this as sine theta is equal to sine alpha, then the meaning is alpha is equal to pi over 6. That's the understanding. So 4 solutions have to be obtained. That means we start with n is equal to 1 and stretch all the way to 4. 1, 2, 3, 4. That's exactly what we are going to do. So when n is equal to 1, let me write down the solutions here. This is going to give me pi, okay, pi plus n is equal to 1. That's going to be negative there. So let me place a negative sign followed by pi over 6. So this is going to be 5 pi over 6. That's a next value, right? So this is going to be 5 pi over 6. Okay, so now when n is equal to 2, so when n is equal to 2, this is going to be 2 times pi negative 1 raised to the power of 2. That's going to be positive, and followed by pi over 6, and this is going to be 6 times 2, right? 6 2s are 12, 12 positive 1, that's going to be 13 pi divided by 6. Now this 13 pi over 6 is going to be falling over here, 13 pi over 6. Now I have taken n is equal to 1, n is equal to 2, and the next value is n is equal to 3, because those counts for n would complete the 4 solutions that we are talking about here. So n is equal to 3 would give me, this is going to be 3 pi, right, negative pi over 6. So this is going to be 18 pi minus pi divided by 6, which is going to be equal to 17 pi over 6, right? 17 pi over 6, and that is going to be over here, 17 pi over 6. So if you were to be talking about the solutions, we need here, let me write down the solutions. Pi over 6, okay, this is for sine value, pi over 6, 13 pi, in fact I need to follow it up with 5 pi, okay, 5 pi over 6, 13 pi over 6, and 17 pi over 6. We are not finished yet, but an important observation that we need to take into account is that we have taken theta to be equal to 2x, and these are the values that we have obtained for theta. So this is going to be 2x here. So we need the value of x. So let me write down the values of x. So this is equal to x being, so pi over 12, right? You got to multiply by 2, comma 5 pi over 12, comma 13 pi over 12, comma 17 pi over 12. I know we have a little bit restrictive space, so I'm trying to give you the entire solution in one go. So these are the values of x for this particular question, students. I hope you enjoyed this. Students, we've been given this question and we are expected to prove this using the identities that we have studied. Now in the numerator we got cos 4t negative cos 2t. In the denominator we got sin 4t positive sin 2t. So having got this information, I will start off by stating this. Consider the left hand side. So I would be rewriting cos 4t followed by negative cos 2t divided by sin 4t positive sin 2t. Now we know that cos A negative cos B is equal to negative 2 times sine of A positive B divided by 2 times sine of A negative B divided by 2. Also, we know that sine A positive sine B is equal to 2 times of sine of A positive B divided by 2 times cos of A negative B divided by 2. So we will be using these two formulae in the left hand side. So if we were to do that, so this is going to be equal to, so therefore the left hand side will be rewritten as negative 2 times sine of 4t positive 2t divided by 2 times sine of 4t negative 2t divided by 2 over 2 times sine of 4t added with 2t divided by 2 times cos of 4t negative 2t divided by 2, which is equal to, the 2 and the 2 can be cancelled. I got a negative sign there. Now these two components will get cancelled. I've got sine of 4t negative 2t will give me 2t divided by 2 over cos of 2t divided by 2. So 2 and 2 gets cancelled, 2 and 2 gets cancelled. So this is going to be negative sin t divided by cos t, which is nothing but negative tan t, which is what is required. So this is the requirement. So this is equal to right hand side, hence proved. So you got to state that. So we given another question. We are expected to prove cos of A positive B divided by cos A multiplied with cos B is equal to 1 negative tan A times tan B. So what I will do is I will start off by considering the left hand side, which is cos of A positive B divided by cos A cos B. Now we got a formula. What is that? Cos, we know this, cos of A positive B is equal to cos A cos B positive sign, so it's going to be negative sin A sin B. So if I were to use this, using this, if I were to take this to be as 1, hence the left hand side of 1 becomes, so in place of this I'm going to write cos A cos B negative, in fact I should use lowercase, right, A and B, followed by sin A sin B divided by cos A cos B. Now we know from algebra A positive B divided by C is written as A over C positive B over C. So by that fact this is equal to cos A cos B divided by cos A cos B negative sin A sin B divided by cos A cos B. Cos A can be cancelled, cos B can be cancelled, giving me 1 negative sin A over cos A. I can rewrite it like this, multiplied with sin B over cos B. This is equal to 1 negative sin A over cos A is tan A, sin B over cos B is tan B. Now what is this? This is nothing but the right hand side. So this is equal to right hand side, hence proved. Students, let's do some questions using the double angle formula. Now I've given you several formulae. Now you can check the lesson video on that. And foremost, let us start with sine 2 alpha. Now I'm going to write, I've given you the formula, but yet I would like to derive the formula here. Now I can write sine 2 alpha as sine of alpha positive alpha, and then I would use sine of a positive b, compound angle formula, which is nothing but sine a cos b positive cos a sine b, right? So that would mean this can be rewritten as sine alpha times cos alpha positive cos alpha times sine alpha. Now I got a sine alpha cos alpha, sine alpha cos alpha. I can add them down, thereby leading me to obtain 2 times sine alpha times cos alpha. So this would mean sine 2 alpha is equal to 2 times sine alpha times cos alpha. This is a famous identity. Now, having got this, let me just apply this identity in solving a simple question, right? Probably. Let's do this. This is an example. The question is express, say, 14 times sine 6x times cos 6x in a single term. So that's a question. So now what I wish to do is I would like to write it in this fashion, right? So 2 should be there, sine 6x is there, and cos 6x is there. Now since I've taken 2 inside, there should be a 7 there, right? Now if I were to take theta to be as 6x, then this can be rewritten as 7 of 2 times of sine theta times cos theta, which is equal to 7 times of, now 2 times sine theta cos theta is equal to sine 2 theta, sine 2 theta, but my theta is 6x, so this is equal to 7 times of sine of, if I were to place 6x here, this is going to become 12x. So what's the solution? Solution is nothing but 7 times sine of 12x. That's the answer. Now let's do this question. We have been given cos of 9 over 2 times x times sine of 9 over 2 times x. Now whenever you got a product of sine and a cos, you can very well use the popular sine to alpha formula or sine to theta. So we know that sine to alpha is equal to 2 times sine alpha times cos alpha. Now consider this quantity. Consider, I'm not going to write it as cos and sine, I'm going to write it as sine 9 over 2 times x times cos 9 over 2 times x, right? AB is equal to BA. So I will multiply this by 2 and I'm going to divide by 2. So 2 over 2 times sine 9 over 2 times x cos 9 over 2 times x, and then I'm going to rewrite this as 1 over 2 and I'll move this 2 inside. So it's going to be 2 times sine of 9 over 2 times x times the cos of 9 over 2 times x. Now let me take theta to be equal to 9 over 2 times x, right? So that would mean this is going to be equal to 1 over 2 times of 2 times sine theta times cos theta. But what is this? 2 times sine theta cos theta. That's going to be sine 2 theta. But what is theta? my theta is 9 over 2 times x, right? So 2 can be cancelled. This is going to be 1 over 2 times sine 9x. This is the solution to this question. So actually what they're asking is that they want us to write this particular term as a single term. So that's exactly what we have done here. Let's do another question, students. We are expressing the given terms as a single term, so we will be continuing to answer questions in that similar fashion. So this is question number 3. So we're given that cos squared 5x negative sine squared 5x. We are asked to express this as a single term. Now we know that cos 2 theta is equal to cos squared theta negative sine squared theta. So hence cos squared 5x negative sine squared 5x can be rewritten as, if I were to take theta to be equal to 5x, then this is going to be cos squared theta negative sine squared theta, which is going to be cos 2 theta. But since theta is equal to 5x, this is going to be equal to cos of, or in other words cos followed by 2 of, in place of theta you replace 5x, so this is going to be cos 10x. So that is going to be the solution for this particular question. Now question 4, we've been asked to write 3 negative 6 times cos squared 8x as a single term. So foremost, what I wish to do is I would like to rewrite this by taking 3 out. If I were to take 3 out, this is going to give me 3 of 1 negative 2 times cos squared 8x. Now let me take theta to be equal to 8x, and hence this can be rewritten as 3 times of 1 negative 2 times cos squared theta. Now if I were to take the negative sign out, then this is going to be negative 3 of negative 1 positive 2 times cos squared theta, which can however be rewritten as negative 3 times of 2 times cos squared theta negative 1, right? But this is nothing but cos 2 theta, so this is equal to negative 3 times of cos 2 theta. But what is theta? Is equal to 8x, so it's going to be negative 3 times cos of 2 times of 8x, which can be rewritten as negative 3 times cos 16x. So that is going to be the solution for this question. So let us move on to do question number 5. We've been given 6 times tan 5x divided by tan squared 5x negative 1. Now we will be using the following formula. We know that tan 2 theta is equal to 2 times tan theta divided by 1 negative tan square theta. Now if there is theta here, theta should occur here, so do not change the variable. For example, if you were to write theta here, you cannot write x here. That is totally incorrect, so please be aware of that particular fact. So we are going to use this formula, and we are going to completely represent this quantity as a single term. So foremost, what I wish to do is I would like to place 2 there and take 3 out. So this is going to be 3 of 2 times tan 5x divided by, I would like to take negative sign out, so this is going to be 1, because 1 times negative gives me negative 1, followed by, there should be a positive sign for tan squared x, so I need to place a negative sign here. So this is negative tan squared of 5x. Now if I were to take theta to be equal to 5x, then I can rewrite this as 3 times of 2 times tan theta divided by, a negative sign is here, so let me place a negative sign there. So this is going to be 1 negative tan squared theta, which is nothing but negative 3 times of, as I mentioned to you, 2 tan theta divided by 1 negative tan square theta is tan 2 theta. So this is going to be tan 2 theta, which can either be represented also as negative 3 times tan 2. My theta is 5x, so place that 5x there, which is equal to negative 3 times tan 10x. So that is the solution for this question. Now, having got this, let us head on to prove some identities. Students, we are going to be using the double angle to prove some important identities. Now, the first question is, we are asked to prove sine 6x over 1 positive cos 6x is equal to tan 3x. Now, what I wish to do is, I would like to write this. Foremost, let me just consider the left-hand side. So that's going to be sine 6x divided by 1 positive cos 6x. Now, I wish to write sine 6x as sine 2 times of 3x divided by 1 positive cos 2 times of 3x, right? So clearly you can see that we can easily apply sine 2 theta formula and cos 2 theta formula. Let me write that down. Since sine 2 theta is 2 times sine theta cos theta, and cos 2 theta is equal to 2 times cos squared theta negative 1. I'm specifically using this formula for cos 2 theta. So if I were to substitute them, this is going to give me, assume that theta is taken to be as 3x, right? So visualizing that, write the formula. So this is going to be 2 times of sine theta, so sine 3x times cos theta, so cos 3x, divided by 1 positive of cos 2 theta is 2 times cos squared 3x negative 1. So removing the parenthesis, this is going to be equal to 2 times of sine 3x times cos 3x divided by 1 positive 2 times of cos squared 3x negative 1. Positive 1 negative 1 gets cancelled, and that would give me 2 times of sine 3x times cos 3x divided by 2 times of cos squared 3x. 2 can be cancelled. A cos and a cos 3x can be cancelled, giving me sine 3x divided by cos 3x, which is tan 3x, which is right hand side, hence proved, right? You see that? And that is the end for this particular question. We are asked to prove this question, students. Cot x negative tan x is equal to 4 times cos squared x negative 2 divided by sine 2x. Now in this case you can either use the left hand side or you can use the right hand side, so depending upon your choice. So what I wish to do is I would start with the left hand side. So consider the left hand side. It's going to be a little bit lengthier if we use the left hand side, but if we were to use the right hand side, the solution would be quicker. Probably, let me just try both sides. So consider the right hand side. Right hand side is 4 times cos squared x negative 2 divided by sine 2x. So if I were to take 2 out, this is going to be 2 times cos squared x negative 1 divided by sin 2x. Now 2 times cos squared x negative 1, that's going to be cos 2x, and you have a 2 there, and you got sin 2x here, right? Cos 2x, if I were to write it as cos squared x negative sin squared x divided by sin 2x. So I'm just moving on right from here, right? So assume that there isn't any strike. So this is equal to 2 times of cos squared x negative sin squared x divided by sin 2x is going to be 2 times sin x cos x. So 2 gets cancelled. Now you got a negative b divided by c. I can rewrite this as a over c negative b over c, right? The algebraic property. So from that, this is going to be cos squared x divided by sin x cos x. So a cos and a cos gets cancelled, followed by sin squared x divided by sin x cos x. Sin gets cancelled. So this is giving me cos x divided by sin x negative sin x divided by cos x. Cos x over sin x is cot x. Sin x over cos x is tan x, which is nothing but the left hand side, hence proved. Right? So that is actually taking the right hand side. Now let us consider the left hand side, okay, which is, this is cot actually, right? This is cot. So cot x negative tan x, this is what has been given. So let me take this as cos x over sin x and tan x as sin x over cos x. Now if I were to take the LCM as sin x cos x, this is going to give me cos squared x, this is going to give me sin squared x. Cos squared x negative sin squared x is cos 2x divided by sin x over cos x. Now what I wish to do is I would like to multiply the numerator by 2 and divide by 2. So 2 times cos 2x, I'm just retaining it as it is. So cos 2x, now I would like to write cos 2x as 2 times of cos squared x negative 1, and I have 2 times sin x cos x. So 2 times sin x cos x is nothing but sin 2x. So this is equal to 2 into 2 gives me 4 times cos squared x negative 2 divided by sin 2x, which is equal to right hand side, hence proved. Right, so I have actually taken 2 sides, both the sides, and I've shown you the proof. It's up to you. You don't have to use both the sides. It's just sufficient enough that you focus on one side and extract the solution to the question. So this is all about using double angle identity. Let's do this question, students. This is a bit different. We are expected to find the double angles given the following. So given tan A is negative 2 and that A is lying between 2 pi and 3 pi over 2. So with this information, we are expected to find the exact value of sin 2a secant 2a, and the third one is tan 2a. Now let me draw the quadrant. So this is going to be 0, pi over 2, this is pi, this is 3 pi over 2, and this is going to be 2 pi. And we are asked to extract these values given that A lying between 3 pi over 2 and 2 pi. So this is the quadrant that the angle is lying. So this is the fourth quadrant. In fourth quadrant, tan is negative, sin is negative, and only cos is positive in fourth quadrant. So let me draw this triangle, right triangle. So you got the complete right triangle to work with. Now we have been given, so if I were to take this as A, this is opposite side, and this is adjacent side, and this is hypotenuse side, right? Now tan A is opposite side divided by adjacent side, so which is given to be as -2. I can rewrite this as -2/1. So you don't have to take the negative sign when you are placing the value. So opposite side is 2, adjacent side is 1. Now to get the hypotenuse, we take the square of this, add it with square of this, and take the entire square root. So if I were to take this as O, A and B, so this is going to be OB squared plus AB squared is equal to OA squared. My OB squared is 1 squared, my AB squared is 2 squared, so 1 added with 4 would give me 5, so this is my OA squared. So therefore OA is root of 5 units. So this is the hypotenuse. But given the value for hypotenuse, I can take the value for sine. So sine A is nothing but opposite side by hypotenuse side. My opposite side is 2, my hypotenuse side is 5, root 5. Now a very important observation we need to make here, sine is negative, so you need to place that negative sign there because of the quadrant. Next is cos A. Cos A is adjacent side divided by hypotenuse. My adjacent side is 1 and my hypotenuse is root 5, so this is positive. It is highly imperative that these signs are mentioned, right? You exclusively make it a habit to place the sign because of the information given to us. Now having got this information, let me solve the first question. First question says sine to A. Now we know the formula, double angle for sine to A, which is nothing but 2 times sine A, cos A, which is nothing but 2 times. Sine A is -2 over root 5. Cos A is 1 over root 5. 2 times 2, 4 with a negative sign. Root of 5 times root of 5 gives me 5. So the value is -4 over 5. So that is for sine to A. Now let me go for secant to A. Secant to A is nothing but, secant theta is nothing but 1 over cos. So this is going to be 1 over cos to A. I'm going to use the formula for cos to A as cos squared A negative sine squared A, which is equal to, my cos is 1 over root 5 raised to the power of 2, negative, my sine is -2 root 5 raised to the power of 2, which is equal to 1 over root 5 raised to the power of 2 gives me 1 over 5. Negative 2 raised to the power of 2 is positive 4 divided by 5, right? So this is going to be 1 over, so this is equal to 1 over 1 -4 would give me -3 over 5. If you were to flip it, you get 5 over 3 with a negative sign. So this is the value for secant 2A. Now tan 2A is also asked. We are expected to find the value of tan 2A. Now tan 2A is nothing but 2 times tan A over 1 negative tan squared A. Now we got the value for tan A. It's already given in the question. Tan A is -2. So place the value -2 divided by 1 -2 square. This is going to give me -4 divided by 1 -2 squared is going to be -4, which is nothing but -4 over 1 -4 would give me -3. These two negatives gets cancelled, giving me the solution as 4 over 3. Students, now we are going to be using half angle identities, right? And we would see how exactly to apply them. So this is more to do with the application part of this concept. I've already given you the formulae for half angle, and yet so whenever there is a question coming up using half angle, I will suggest or I will state the relevant half angle formula that is going to be applied. So foremost, we are expected to solve this question. So the question is, determine the exact value sine pi over 12 using half angle identity. Right, this is the question that's being asked. Now foremost, I would have to determine the formula. Now let me state the half angle formula. Sine alpha over 2 is equal to root of 1 negative cos alpha over 2 if alpha over 2 is located in the first or second quadrant. Otherwise, sine alpha over 2 is equal to negative square root of 1 negative cos alpha over 2 if alpha over 2 is located either in the third or fourth quadrant. So having mentioned this, it becomes imperative that we find out in which quadrant pi over 12 is. Now pi over 12 is given as a radian measure, so I want to convert it into degrees. Hence you multiply by 180 over pi. So pi gets cancelled, giving me 180 divided by 12. If you were to divide 180 by 12, you will get 15 degrees. So this would mean pi over 12 lies in the first quadrant. So that would mean all ratios are positive. All ratios are positive in the first quadrant. So that's the first thing that we need to do. So after we have done that, we would be now utilizing this formula. Hence, the required formula is sine alpha over 2 is equal to square root of 1 negative cos alpha over 2. Now, but we are given, what are we given? We are given sine pi over 12. So that would mean in place of alpha over 2, we got pi over 12. So that means we need to know what is alpha. So this means alpha is equal to 2 times, I'm just cross multiplying, so it's going to be 2 times pi over 12, which is nothing but pi over 6, which implies the value of alpha is pi over 6. So take the value of alpha and substitute it here. So therefore sine pi over 12 is rewritten as sine, in place of alpha we got pi over 6 divided by 2, right, which is equal to square root of 1 negative cos alpha is pi over 6 divided by 2, which is equal to root of 1 negative cos pi over 6, that's nothing but cos 30 degrees. Cos 30 divided by 2. Now what is cos 30? Cos 30 is root 3 over 2. So I need to substitute that. So it's going to be 1 negative root of 3 divided by 2 divided by 2, which is nothing but 2 negative root of 3 divided by 2, and you got a divided by 2 and you got a square root, which is equal to 2 negative, in fact let me write it like this, 2 negative root 3. If I were to flip this denominator, it's actually 2 over 1. So if I were to flip it, I would be having something like this, 1 over 2 with the square root, which is nothing but root of 2 negative root 3 divided by 2 times of 2 into 2 gives me 4. So this is the exact value of what? Therefore sine pi over 12 is equal to square root of 2 negative root of 3 divided by 4. Of course you can rewrite this further as 2 negative root of 3 divided by root of 4 will give you 2. So this is a positive value, so positive, so that's going to be the solution. Students, we are expected to solve the trigonometric equation of this form: sine squared theta is equal to 2 times sine squared theta over 2, where theta lying in the interval 0, 2 pi. So foremost, what I would do is I would use this formula. We know that because we need to consider this entire system as a single equation, and then we need to proceed. So we are going to use the half angle formula. So we know that sine alpha over 2 is equal to root of 1 negative cos alpha divided by 2. So we will be using this formula. So if I were to take this as 1, therefore I can rewrite 1 to be as sine squared theta is equal to 2 times of root of 1 negative cos theta divided by 2 raised to the power of 2. So this would mean I now have sine square theta is equal to 2 times of the square and the square root, they get neutralized, giving me 1 negative cos theta divided by 2, right? Because the entire quantity is within the square root. So the 2 and the 2 can be cancelled, giving me sine square theta is equal to 1 negative cos theta. I want to take everything to the left side. So if I were to take everything to the left side, I would get sine square theta negative 1, this becomes positive cos theta is equal to 0. Now if I were to write sine square theta as 1 negative cos square theta, then I've got 1 negative cos square theta, negative 1 positive cos theta is equal to 0. Negative 1 positive 1 gets cancelled. So now I got cos theta negative cos square theta is equal to 0. From here I can take cos theta out, so that's going to give me 1 negative cos theta is equal to 0. From here I got cos theta is equal to 0 or 1 negative cos theta is equal to 0, from which I got cos theta is equal to 1. Graph of cos. So when theta is equal to 0, cos it's 1. So the graph will start to look like this, right? And at pi over 2, cos pi over 2 it's 0, and at pi it will hit negative 1, and at 3 pi over 2 it hits 0, and at 2 pi it hits 1, right? So if you were to examine cos theta is equal to 0, in other words the values for which cos theta will be equal to 0 would be the following. When theta is equal to pi over 2, it's going to be 0, and 3 pi over 2, and so on it goes. But apparently our restrictive interval is 0 to 2 pi. Now next is cos theta is equal to 1. So we need to study this also. Now cos theta is equal to 1 for what values? Clearly theta should be equal to 0, and at pi it's negative 1, we can't take that, and at 2 pi it is hitting 1. So if you were to sum up all these things, so therefore the possible values of theta given the interval 0, 2 pi is going to be 0, pi over 2, 3 pi over 2, and 2 pi. So this is the solution. Students, we got a good question. We are expected to find the value of cos 112.5 0.5 degrees, right? So how are we going to do this? Now what I wish to do is I would like to rewrite this degree cos 112.5 degrees. This is what has been given. So I would like to rewrite this as multiplied by 2 and divided by 2. So what happens here? This is going to be equal to cos 225. When you multiply 112.5 by 2, you get 225 degrees, right? So degree, that symbol is there, divided by 2. So what are we going to do is we are going to find the value for this. Now this is nothing but this is likened to the value of cos alpha over 2, where I can state alpha being equal to 225 degrees. So that is the initial adjustments that we have to do. Now this is going to be our half angle. Now we know that cos alpha over 2 is equal to root of 1 positive cos alpha divided by 2. So alpha is 225, so we will have to place 225 there. So therefore cos of 225 over 2 is going to be equal to root of 1 positive cos 225 divided by 2. Now if we know the value of 225, this question is completed, it's finished. So the value of 225, how are we going to get the value of 225? Now 225 can be written as cos of 180 positive 45, right? Now this is similar to our cos of a positive b. So what is that? That's nothing but cos of 180 times cos 45 negative sine of 180 times sine 45. Now sine 180, that leads us to 0, so there's no point in keeping that. So all we got is cos 180. Cos 180 we know it's negative 1, and cos 45 is nothing but 1 over root 2. So we got a value of negative 1 over root 2 for our 225. And what we can do is just to have the calculation, right, simplified. I'm going to multiply this by root 2, divide by root 2. So this is going to be negative root 2 divided by root 2 multiplied with root 2 would give me 2. So this value I can always use. So if I were to take this as 2, I can state here, therefore 2 is rewritten as root of 1 negative root 2 over 2 divided by 2. So the root actually flows. This is equal to root of 2 negative root 2 divided by 2. I already have 2 here, so that would come over to the denominator, thereby giving me 2 times 2 4, but I can in turn rewrite that as square root of 2 negative root of 2 divided by 2, right? So this is what we have got. Now there is one important thing that we need to know. Now you need to get hold of the sign. So how are we going to handle that sign? Now if you were to draw the quadrants, this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. Now if you would remember, I had made the rule for taking the value of root of 1 positive cos alpha divided by 2, the half angle rule. In fact, that rule is the universal rule, and it states that this can be positive if the value of alpha over 2, if this value lies either in quadrant 1 or in quadrant 4. Apparently 112, the value 112.5 degrees is present in quadrant 2 where sine alone is positive. In this quadrant, cosine value is negative, right? So what we got to do is we will have to now place the sine, because cosine of 112.5 degrees is going to give us a negative value because of the fact it is present in quadrant 2. So place the sine. Of course, I have not placed the sine initially to avoid any confusions, because we are actually performing two different operations using a different identity. This is the compound angle identity. So it's always better to solve it, get the extraction, and then talk about the sign, decide on the sign. Now, if you were to come across here, the sign is going to be negative, the sign is going to be negative, the sign is going to be negative. So this is the final solution. So you can simply state here, so hence cos of 112.5 degrees is equal to negative root of 2 negative root of 2 divided by 2. So this is the solution, and it is only valid when you place a negative sign. So don't forget the negative sign. So having mentioned that, this is a lovely question to experience half angle trigonometry. Let's do another question, students. We've been asked to find the exact value of sine 105 degrees. Now, the power of the half angle is that without even using any calculating devices, we will be able to extract this value. Now, let me show you that. Now, what I would like to do is I would like to rewrite sine 105 degrees by multiplying it with 2 and dividing it by 2. So this is going to give me sine of 210 degrees divided by 2, which I'm going to write it as sine alpha over 2, where the alpha value is equal to 210 degrees. Now we know this formula. We know that sine of alpha over 2 is equal to root of 1 negative cos alpha divided by 2, of course depending upon where the value of alpha over 2 lies. In this case it's going to be positive for the very fact it's 105, and that is present in quadrant number 2 where sine is positive. Now this in turn can be applied, so therefore sine of 210 degrees divided by 2 is going to be equal to root of 1 negative cos 210 degrees divided by 2. Now the question comes here is, what is cos 210 degrees? Now that's nothing but cos of 180 degrees positive 30. Now I'm going to apply cos of A positive B formula. So that would give me cos 180 times cos 30 negative. When you got a positive sign, the formula takes a negative sign when you place the expression on the right side, followed by sine 180 times sine 30. Sine 180 is going to produce 0, so there's no point in retaining it. So all we got is cos 180, which would give us a negative 1, and you got cos 30. Cos 30 is root of 3 over 2. So you got a value in this fashion, negative root 3 over 2 for cos 210 degrees. So if you were to take this as 2, I can now rewrite, therefore 2 is equal to root of 1 negative. Now there is a presence of a negative sign, so we need to take hold of that. So we take this and we substitute it right into 2. So this is going to be 1 negative of negative root of 3 over 2, and you got a 2 there in the denominator, so I would place it in this fashion. Now this can be further rewritten as square root of negative will become positive, 1 positive root of 3 over 2 divided by 2, which is equal to root of, I'm going to take 2 as the LCM here, so this is going to give me 2 positive root of 3 divided by 2. There is a 2 here, so that's going to become 2 squared. Now if I were to apply the square root for the numerator and the denominator, I would get root of 2 positive root of 3 divided by 2. Now as I mentioned to you, 105 degree which we are talking about lies between the angles 90 and 180. In fact, this is quadrant 2 where sine is positive, right? So this is going to be producing a positive value, and on the left you got sine 105 degree. So this is the solution for the question. So a point of observation is that though we have a negative sign here, cos of 210 degree which we are calculating is producing us a negative root of 3 over 2, and that is the reason when I place the value negative root of 3 over 2, it becomes positive here. So that is a very important observation that you will have. Students, now it's time for us to understand polar coordinates. Now all these times we are dealing with what is called as Cartesian coordinate system. Now in this coordinate system we deal only with x and y. So suppose you are looking to plot a point, say 2, 3. If I were to plot this point 2, 3, the system that I am using here is called the Cartesian system. So when I say x is equal to 2 and y is equal to 3, the understanding is from the y-axis the point is located 2 units away, and from the x-axis the point is away by 3 units. So that is the understanding that we need to have when we are talking about Cartesian coordinates. Now coming to the point of polar coordinates, if each point of course we are talking about two-dimensional system, of a two-dimensional coordinate system, is identified based on the distance from a reference point. I'll explain to you what exactly the term reference point is, and an angle taken from a reference direction then such a system is known as polar coordinate system. So the same x and y which I've just shown you here, it can be represented in this fashion. So I got the point there and the line is drawn. This is the origin. We call this point as the pole, and this distance is r and this angle is theta. So this point is going to be r comma theta. Now if you were to drop a perpendicular, this point is away from the so-called, I can't mention here as x-axis here, I shouldn't do that, just for the sake of understanding. This is away from the x-axis y units. You don't have to mention it here, just for your understanding, and it is away from the y-axis x units. So this is what I've just explained to you here, but in this case it is more graphically represented. So having got that, there are a few things we will have to know. when we are talking about the polar coordinate system. So as I mentioned to you, pole, okay, when we talk about pole, it means the reference point. You got to know this. And then polar axis. So this is nothing but the line segment from the pole in the reference direction. So in this case, when we talk about polar axis, we are talking about this line, right? And as I mentioned to you, the origin is called as the pole. So this is the starting point. And x comma y is represented as r comma theta. Now, when we mention the letter r, we are obviously talking about the unit circle, and this is the radius, right? So that has to be taken into account. You need to know what is called as a polar grid. So let me write that down, polar grid. And how does it look? So it starts with 0 over here. So I will try to draw a miniature version. So 30 degrees is over here. This is 30, and this is going to be 60, and you got 90 over here, and then over here it's 120, and over here it is 150, and you got 180 here. So this is 90, 30, 60, 120, 150, and then over here you got 210, over here you got 240, and over here it's 270. Right over here you got 300, and over here you got 330 and 360. So if you were to connect them all, I'm trying to get a circle. Okay, that's fine. So let me write these points down. 210, 240, 270. This point is 270. This is 300, 330, and you got 360. Right, so this point is 0, 360. So that's nice. So probably you can draw the poles, I should say the polar axis. Now, in between, you can have infinite number of polar axes. And it is imperative to understand that one particular point has got infinite number of polar representation. That is a noteworthy point you need to know. And given r, you can always extract the negative part. Say for example, you are given r comma theta positive 2 and pi. You can always find a negative r located at theta positive 2 and positive 1 times pi. So this formula will come in very much handy when we are dealing with polar coordinates. Now theta is positive if measured in anti-clockwise direction. Anti-clockwise. So anti-clockwise means in this direction, Okay, let me show you. if you are moving up like that, and if you are moving in clockwise direction, theta is negative if you are moving in clockwise direction. So clockwise direction means like this, right? This is the way clockwise, and anti-clockwise means like this. So from here, this is positive, 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 positive. And if you were to move counter in the sense, counter the direction which I just mentioned, the negative, 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 right? So have that in mind. So that's the basic thing. Now, having given you that, let's move on. Next comes the relationship between Cartesian and polar coordinates. Now we know x and y are Cartesian, and the formula connecting them is x is equal to r cos theta and y is equal to r sin theta, and r squared is given to be as x squared positive y squared, which can easily be obtained, and r from here is equal to root of x squared positive y squared. And if you want to get the value of theta, you have to calculate the y over x value. So y over x will be equal to tan theta, and from here theta is equal to tan inverse of y over x. So this gives the argument, this gives the magnitude. So it's a very important concept that you will have to know. So we are dealing only with two-dimensional trigonometry. In other words, the r and theta value alone we are associating with. Probably when we move up, we can bring in three-dimensional geometry also. But for now, we will just restrict ourselves to two-dimensional geometry. So having mentioned this, let me just give you a simple question. The question is, convert Cartesian to polar form, right? We are being given 2, 2. So we have to convert this into polar coordinates. So this is my x and this is my y. Now r is equal to root of x squared positive y squared, so which is nothing but root of 4 positive 4, which is nothing but root of 8. So that is going to give me 2 times root 2. And theta is nothing but tan inverse of y over x, which is going to be equal to tan inverse of 2 over 2, right? And that is going to be equal to tan inverse of 1, which is nothing but pi over 4. So therefore my r comma theta is equal to 2 times root 2 comma pi over 4. So this is interesting question. So students, let's do this question. We are expected to plot this polar coordinate m of 2 comma pi over 2 and followed by n of 3 pi over 4. Now foremost, let me draw the circle. Now this is 2 units and this is 3 units. So let me start off with 1 unit. So this is r is equal to 1, and moving up, this is r is equal to 2, and moving still further up, this is r is equal to 3. Now you don't have to be really precise, but just a close approximation is sufficient enough. Now having got that, r is equal to 2 is over here, but it's pi over 2. As I mentioned to you in the earlier classes, I have clearly drawn the circle with all the degrees. So we start here with 0, and then this is going to be pi over 2, this is pi, and this is 270, 3 pi over 2, and this is going to be 2 pi, this is 360. Now They're asking us to find m of 2 comma pi over 2. So that point is going to be over here, right? So that is the solution for this part of the question. Now we need to move up for n of 3 comma 3 pi over 4. Now what is 3 pi over 4? Let me calculate. Pi over 4 will give me 45 degrees. So 3 times 45, 3 5s are 15, 1, 3 4s are 12, 13. 135 degrees. This is 180 degrees. So clearly, if you remember, I have plotted 130 degrees in the previous question. And we have 135. So 135 would be somewhere over here. So this is the point that we are looking for. So you can simply circle that point, and what you can do is you can connect it to the pole. This is the pole. I mentioned to you 0 is the pole. So this is going to be my n of 3 comma 3 pi over 4. So these 2 points we have plotted. Of course, if you want, you can just have a blue lining over there just to indicate that you have plotted the point. So that is for it. Now let me ask you this question. Imagine this line is stretched from here onwards to this particular point. This is a straight line, right? And you are expected to find the coordinate of this particular point. So what would your answer be? I know the angle for this. I know the theta value, that is 3 pi over 4, but I do not know the theta value for this. Imagine this point is C and you are expected to find the coordinates for this particular point. Now R is not going to be changing, right? Because I already mentioned to you when I started, this is R is equal to 1, R is equal to 2, and R is equal to 3. So if the point is present on the last ring, R value is 3, and if the point is present on the second ring, R value is equal to 2. So that's a simple thing. So R is equal to 2 is found out. But the question now is, what is the value of theta? We know the value of theta over here is 3 pi over 4. Now if you want to get this value of theta, you can clearly see here, theta is actually making pi turns. From over here, it has to move all the way to reach this particular point, right? The only thing is that it is on R is equal to 2. So to get that value of theta, all you need to do is add pi. So that is going to give me 3 pi positive 4 pi divided by 4, which is equal to 7 pi divided by 4. So the theta value here is 7 pi divided by 4. So what would that be? This is going to be 7 times 45, which is nothing but 7 5s are 35, 3, 7 4s are 28, 29, 30, 31, 315 degrees. So this is 135 degrees. And if you want to come over here, this is actually 315 degrees. So I can write that down, 315 degrees, and this is actually 135 degrees, just for your understanding. Okay, now having got that, let me move up a little bit further, say over here, right? Now let me give you a value of r comma theta, say some point D. Okay, I'm taking some point D over here, and they are giving you the r value. That's clearly obvious. That's going to be 2, comma, and the theta value, say pi over 4, and they are actually expecting you to find this point F. What is the r value for this and the theta value for this? This is what is expected from you. Now clearly, if you were to draw the line connecting this and this, it's actually a straight line. So as I mentioned to you, theta is actually, now we are moving with the anti-clockwise. So theta is actually traveling 180 degrees, right? So in this case, we are adding pi. So if we were to add pi, I got pi over 4 positive pi. This is going to be pi plus 4 pi divided by 4, which is going to be 5 pi divided by 4. Now what is this 5 pi divided by 4? That's going to be 225 degrees. Now this is 270 degrees, right? And clearly this is going to be 225 degrees. So this is 225 degrees. This is 270 degrees. So the value of f, so therefore the coordinate system for f is going to be r is 3 units, comma 225 degrees. So we don't write it as 225 degrees, we give a radian measure. So the radian measure has to be placed. So let me change this. Okay, 5 times pi over 4. So that is the solution. So I hope you got an idea as to how you can get the values for theta. And you have to understand that one particular coordinate in a polar system can have infinite number of representation. So that is the beauty of it, for the very fact that we are dealing with circles. Let's do this question, students. We are expected to convert 10, 30 degrees, this is actually r comma theta, into Cartesian coordinates. Cartesian coordinate system x comma y. Now I've already given you the representation connecting Cartesian and polar coordinates. So let me write that down. Convert polar to Cartesian. And that relationship between Cartesian and polar coordinate is as follows. X is equal to r times cos theta. This is one representation. And for y is equal to r times sin theta. Now clearly from the given question, we know that the value of r is equal to 10 and the value of theta is equal to 30 degrees. So therefore x is equal to 10 times cos of 30 degrees. Now cos 30 is root of 3 divided by 2. So this can be written as 2 divides 10 5 times. So this is going to be 5 times root 3. So this is my value of x. So x is equal to 5 times of root 3. Now coming to y the value of r is 10 and this is sin 30. And we know that sin 30 is 1 over 2. So this is going to give me 5. So y is equal to 5. Now we got x value and we have got y value. Of course, if you are interested, you can use the value of root 3 as 1.7321 and multiply it with 5 if you want. So that's going to be 1.7321 and multiplied with 5. 5 ones are 5, 5 twos are 10, 1, 5 threes are 15, 16, 1, 35, 36, 3. So it's going to be 8.6601. I can take it as 8.661. So therefore the Cartesian coordinate, Cartesian is x comma y is equal to, I got 8.661 comma 5. So this is the final solution for this particular question. So that's a very interesting question which talks about conversion, and we can also simultaneously do the vice versa part, that is converting the given Cartesian to polar coordinate. So convert, I've already done the question on this, but let's do one more question. Convert Cartesian to polar. So you've been given this question 15,8 and you need r comma theta. Now as I mentioned to you, x is equal to r times cos theta and y is equal to r times sin theta, and we know that r is equal to square root of x squared positive y squared. So that's going to be root of 15 squared positive 8 squared. So 15 squared is 225, 8 squared is 64. This is going to be square root of 289. You take the square of this, you get 17. So therefore r is equal to 17. You can have a box of this. And theta also, we know that theta is equal to tan inverse of y over x, which is nothing but tan inverse of my y value is 8, my x value is 15. So this is what we have got. Now of course you can use a calculator. If you were to use a calculator, this would be approximately 28.07 degrees, approximate value. So therefore r comma theta is going to be equal to 17 comma 28.07 degrees. So this is the solution that we have got. Of course you can convert it into radians, it's up to you. And this is in polar coordinates, in polar form. So that's a nice question. So we move on to the next one. Now let's do this question. We are expected to find the polar coordinates for -4, -5. So that's the question. So it's a very interesting question and it will feature in lot of competitive exams as well as in examinations conducted by various boards. Now draw the quadrants and identify the point. So it's negative for x-axis is negative 4, y-axis is negative 5. So if this happens to be negative 4 and this happens to be, say, negative 5, we are looking at a point, right? This is 0 over here. And if you were to draw and connect this, so this is what you are looking at, negative 4 comma negative 5. So we want to get the polar representation for this. So we know that x is equal to negative 4 from the given question, y is equal to negative 5. So r is going to be root of x squared positive y squared, which is nothing but square root of negative 4 squared added with negative 5 squared. So this is square root of 16 positive 25, which is 1 and 4 root of 41. So if you were to take the square root of this value, which is approximately will be equal to probably 6.41, right? So I'm taking it as r is equal to, I'm not taking any approximation here, I'm just directly taking the value of r to be as 6.4. That's fine. Now theta is given to be as tan inverse of y over x, which is nothing but tan inverse of, my y is negative 5, my x is negative 4, so that's going to be tan inverse of 5 divided by 4. If you were to look up or use your calculator, you will get the theta value as tan inverse of, this is going to be 1.25, and upon calculating this, theta value will be 51.34 degrees. It's an approximation. Now you have to understand that this is not what we want, right? Because 51.34 will be over here, right? But we want theta to be over here. So we are looking for this point on the third quadrant. So to get the value for the third quadrant, as I mentioned to you, we are not interested in the first quadrant value, we are interested in the third quadrant value. So to get the third quadrant value, we have to take the value 51.34 degrees, and to it you got to add pi, that's 180 degrees. So if I were to add 180 degrees, then this value is going to be 231.34 degrees. That's what we really want. That's is the value, because this is going to be 270 and we are looking at a point which is to the left of 270, so that's going to be 231.34 degrees. So clearly, so therefore you can conclude negative 4 comma negative 5 in Cartesian coordinate system as a polar representation being root of 41, which is 6.4, and comma 231.34 degrees, right? So this is the solution. Welcome students, we've been looking into the polar forms, and exclusively we are now going to be looking into the polar form of complex number. Now before I could start off in giving you questions and related solutions with regard to the polar form of complex number, foremost it is imperative that you know what is a complex number. So let me write that statement down. A number of the form z is equal to a positive ib, where a is called the real part and b, the imaginary part, is called a complex number. Now this is the required definition for a complex number. Now you might be asking me, why do we need a complex number? For the simple reason, complex numbers are present mainly to handle negative numbers inside the radical sign. So what is the meaning of this? Suppose you have, say, x squared positive 16 is equal to 0, and you are expected to find the value of x. Now from here you can write x squared is equal to negative 16, and which can be again rewritten as x is equal to root of negative 16. Now this is a radical sign and you got a negative number present inside. Clearly you would say that there exists no real roots, right? Of course this is the right answer if you are not aware of the concept of complex numbers. Now because you are aware of the complex numbers, you can rewrite this value as square root of 16 times I squared, right? Because according to the definition of complex number, I squared carries a value as negative 1, and because of this fact I can write root of negative 16 as root of 16 I squared, and subsequently you can go on to solve it and extract the value for x. Okay, so we are not going into the details of a complex number. We will only be confining our study into the polar representation of any given complex number. So having mentioned that, let me just give you this question. Say this is a question that wants us to obtain the polar form of, say, a complex number of the form z is equal to negative 1 negative I times root 3. As I mentioned to you, the form of the complex number is actually in this way, a positive ib. In this case, clearly a is equal to negative 1, and so this is indeed a complex number. Now how are we going to represent this complex number in polar form? Let me write that statement down. Any complex number as a polar form in the following manner. So I can always write z. So we got z is equal to r times of cos theta positive I sin theta. Now remember this is how we represent a complex number in polar form. Now concurrently we can also represent z to be as r cis theta. So in some of the textbooks you will get to see a representation like that, so you don't have to worry, this is nothing but this. But we will be using this because this comes very much handy in problem solving. So having got this, this can be further rewritten as r times cos theta positive I times r sin theta is equal to z. Now remember always, any z has a representation x positive iy or a positive ib, but in this case I'm just taking it as x positive iy. So if I were to place here x positive iy and write the right hand side term r times cos theta positive I times r sin theta, then equating the real part and the imaginary part, we get, so what do we get from here? Clearly we get x is equal to r cos theta and y is equal to r sin theta. Now this is what I have given you when we started the polar coordinates in the last class. So this is exactly what we are getting, right? So having obtained this, we were going to be solving this particular question. So foremost, clearly from this question you got a quantity here, a real quantity and an imaginary quantity. Now anything with I as a prefix is mentioned as an imaginary quantity. Any quantity without I is mentioned to be as a real quantity. So have that in mind. So having got this, we would also need the value of r. Now remember that the value of r in the last class, I gave you this formula, r is equal to root of x squared positive y squared. So this is all we need to solve questions in polar coordinates, at least for problems connecting or problems concerning forms of this nature. So what I'm going to do is I'm going to solve this question. So we are given, what are we given? We are given z is equal to -1 -I times root 3, and we know that z is equal to x positive iy. So this means x positive iy is equal to -1 -I times root 3. Now from here, equating, as I mentioned to you, the real part, we get x is equal to -1 and y is equal to negative. You don't need to place I, just place the quantity negative root of 3. You got the value for x, you got the value for y. Now you find r. The formula for r is root of x squared positive y squared, which is nothing but square root of -1 raised to the power of 2 positive root of 3 raised to the power of 2. This is going to give me 1. Root of 3 square will give me 3. So you got root of 4, which is nothing but 2. I'm going to be taking only positive value over here. So this is going to be my r. Okay, we have got r. Now concurrently we got this representation to find theta. Now tan theta is equal to y over x. So this means if I were to substitute the value of y, which is negative root 3, and x, which is -1, we are actually getting tan theta to be as root of 3 over 1. So this means tan theta is positive. So go back to the quadrant. You got alpha, pi minus alpha, and then pi positive alpha, and tan is positive over here and positive over here. So if you were to take the value of theta from here, theta is equal to tan inverse of root of 3. Now what is root of 3? This is going to be pi over 3, right? Tan 60. Tan 60 will give me root 3. You can substitute the value of alpha. Alpha is pi over 3. Substitute it there. And then this is going to be 3 pi positive pi divided by 3, which is nothing but 4 pi over 3. Right? So you got 4 pi over 3. So I'm going to use this value. So therefore, the complex number, which is of the form r times cos theta positive I times sin theta, is equal to, in place of r, substitute 2 times, in place of theta, you substitute 4 pi divided by 3 followed by positive I times sin 4 pi divided by 3. So this is the complex number in polar form. So that is the solution for this question. Now you might be wondering, why did I take 4 pi over 3? For the simple fact, just make this observation: x is equal to -1 and y is equal to negative root 3. So if you were to go and plot the points, this is -1 and negative root 3 would be somewhere over here, because root 3 is 1.7321. So if I were to take this as -1, so 1.73, and this is -2, this is going to be somewhere over here. So the angle is actually present in this quadrant, right? -1, come on, negative. So because of that fact, so let's do this question, students. You got question number 2. Represent z is equal to 3 times root of 3. Of course you got the imaginary value I there in polar form, right? So solution, so we can start the solution in the following way. We know that any complex number is of the form x positive iy. We will be taking x positive iy instead of a positive ib or c positive id, because it's always better when we are associating with x and y. No, it's more to do with the coordinate system that we are happy with. So because of this fact, I can now rewrite x positive. This means x positive iy is equal to 3 negative I times 3 times root of 3. Equating, we get x is equal to 3 and y is equal to negative 3 times root of 3. Now we need to get the value of r. So r is equal to root of x squared positive y squared, which is equal to root of 3 squared positive of negative 3 root of 3 raised to the power of 2, which is equal to root of 3 squared is 9. This 3 squared is 9 times 3, that's going to be 27 This is equal to root of 36, which is equal to 6. So my R value has already been obtained, is equal to 6. Now to get the value of theta, tan theta is equal to y over x, which is nothing but negative 3 times root 3 divided by 3, which is equal to negative root 3. So we got tan theta is equal to negative root 3. Now let me just go and plot the point. We got 3 comma negative 3 times root 3. Now if this is going to be 1, 2 and 3, let me calculate the value of 3 times root 3 with a negative sign. Now root of 3 is 1.732. Let me just take it as 1.7. If I were to multiply by 3, 7 3s are 21, 2 3 1s are 3, 4, 5. So approximately you have a value of negative 5.1. So if I were to take this as 3, this as 4 and this as 5, negative 5, the point is going to be somewhere over here, right? 5.1. So this is present in the fourth quadrant. And another important observation is the value of tan theta is negative root of 3. Now of course we have known the value negative root 3 have to be placed into the modular sign, and then subsequently we extract the value as positive root 3, and then we get the value for theta pi divided by 3, because tan 60, let me just take the value of tan 60. Tan 60 will be sine 60 divided by cos 60. Sine 60 is root 3 over 2, and cos 60 is 1 over 2. So subsequently we will get root 3, but we don't need root 3, we need negative root 3 is actually present on this end, right? So we need to get the theta value for that. So we can't just place theta to be as pi over 3, right? For the simple fact there are two things that are actually opposing it. One, the coordinates 3 and negative 3 root of 3, right? Though I've taken it as a positive sign, I cannot just use pi over 3. Actually applying the modulus mainly to get the value, because after getting the value what we need to do, we need to go back and use this popular tool. So what are the tool? Alpha pi negative alpha, pi positive alpha, and 2 pi negative alpha. This is the popular tool we should use. So if I were to use this tool, what will be the value of theta? So this is nothing but 2 pi negative pi over 3. Let me draw the line here. 3 2s are 6, 6 minus pi. This is going to give me 5 pi over 3. So this is the required value of theta. So have this in mind. Of course I just placed in all these things in a small space because of space constraint, and I didn't want to break the momentum, and that's the reason. So I hope you got this idea. Even though you're applying modulus sign and extracting the value, that is basically to obtain the value of theta, but not the final value of theta, which will go into the polar form, right? No, to get that value we need to study the coordinates. I can clearly see it is present in the fourth quadrant, and to get a value in the fourth quadrant we need to use this formula 2 pi negative alpha. What we can do is we can just apply it in the formula and get the final result. Let me go to the new space. So the final solution is going to be z is equal to r times cos of 5 pi divided by 3 positive I times sine 5 pi over 3. So this is the polar representation and our solution. Students, now we are going to be using the theorem from De Moivre's, and it's a very important concept that you will have to know, because using this concept we would have to solve many questions, not only in trigonometry but also in complex numbers. So this is called as De Moivre's theorem. Okay, now what does the theorem states? If z is equal to r times, in fact I need to represent it in this fashion to avoid confusion. So it's going to be r of cos theta positive I sin theta. If there is a representation for a complex number in polar form, then z raised to the power of n is nothing but r times cos theta positive I sin theta. This entire thing is raised to the power of n, and this can be rewritten by De Moivre's theorem as r raised to the power of n times cos n theta positive I times sin n theta. This is the all important formula given by De Moivre, right? So he's a great man to have extracted this beautiful way of simplifying indices, right? Suppose a quantity we raised to the power of this index and say it is n is equal to 10. With this application, the result can easily be obtained. So let's start our problem solving session with this particular question. Evaluate, say 2 times of cos 120 degrees positive I times of sin 120 degrees, and this is raised to the power of 5. Now by De Moivre's, I can actually rewrite this in this fashion. So this is going to be 2 to the power of n times, now let me write 120 in radian measure. Now 120 degrees, you want to convert it into radian, you multiply by pi divided by 180. So 0, 0 gets cancelled. You got 3 dividing 12, 4 times 3 dividing 6 times 2 dividing 2 times 2 dividing 3 times. So this is 2 pi over 3. Radians, RAD stands for radian. So you can use this. So this is going to be cos of 2 pi divided by 3 positive I times sine of 2 pi divided by 3 raised to the power of 5. So if I were to apply De Moivre's, now this I have already placed n there. In fact, assume that there is no n. Okay. Now I'm going to apply. If I were to apply De Moivre's theorem, this is going to be 2 raised to the power of 5 times, as I have shown you here, it's going to be cos n times theta. So cos of 5 times of 2 pi times over 3 positive I times sine of 5 times of 2 pi over 3. So this is what we have got. Now this is equal to 2 raised to the power of 5 cos of 5 times 2 pi, that's going to be 10, right? So 10 pi divided by 3 positive I times sine 10 pi divided by 3. Now 3 and pi is 180, so it's going to be 60, and cos 600. Now this can be easily evaluated. 2 raised to the power of 5 is nothing but 32, and this one would give me negative 1 over 2 followed by negative root 3 over 2. You can watch my videos where I have clearly shown how to obtain the value of cos 10 pi over 3 and sin 10 pi over 3. I will put the link and you can use it as a supportive material. So this is going to be, if I were to distribute 32 inside, I would get negative 16 followed by negative I times 16 into root 3. So this is the solution that we have extracted, and we can move on to the next question. So the next question is also evaluate, and you have got negative 1 over 2 positive I times root 3 over 2 raised to the power of 10. Now this is a Cartesian coordinate system. So if you were to look for the point negative 1 over 2, that's going to be, if this point is going to be negative 1, negative 1 over 2 will be in the center, and root 3 over 2, root 3 is 1.732 divided by 2. So if this point is going to be 1, and we are actually looking for a point which is closer to 1, 0.8, right? So this would be the quadrant. So this is quadrant 2 where our theta is present, and we have been given this quantity. So from here I can clearly write x is equal to negative 1 over 2 and y is equal to root of 3 over 2. This is what we have got, and my r, I can extract the value of r from here, which is from formula x squared positive y squared, which is equal to root of 1 over 2 squared positive root of 3 over 2 squared, which is equal to root of 1 over 4 positive root of 3 square will become 3 divided by 4, which is nothing but root of 1 positive 3 divided by 4, which is going to be 1 unit. R is equal to 1. Now I got the value of R. Now let me get the value of tan theta. Tan theta is equal to this quantity, root 3 over 2 divided by 1 over 2 with a negative sign. This is going to give me negative root of 3. Now as usual, you take the modulus of this and you're getting root 3. So this will mean we are looking at a value, theta is 60 degrees, right? Pi divided by 3. But we are not looking for theta being equal to pi over 3. We want theta to be present in the second quadrant. So over here it's going to be pi negative alpha. So this would mean pi negative pi over 3 is going to be 3 pi minus pi divided by 3, which is equal to 2 pi over 3. So this is the theta that we want, right? So having got this theta, what can we do? We can place it back in the representation. Okay, therefore this means if z is equal to negative 1 over 2 positive I times root of 3 over 2, if this is the complex number, then this is equal to r times of cos theta positive I times sin theta. My r is 1, my theta is 2 pi divided by 3, I can write the same thing, right? 2 pi divided by 3. This is what I've got. But we need to get raised to the power of 10. So this is going to be raised to the power of 10. So therefore z raised to the power of 10 is equal to negative 1 positive I times root of 3 over 2 raised to the power of 10, which is nothing but this entire component raised to the power of 10. By De Moivre's, this is going to be 1 raised to the power of 10 times cos 10 times of 2 pi over 3 positive I times sine. That's going to be, this is going to be 10 times of 2 pi over 3. This is also going to be 10 times of 2 pi over 3. This is what I've got. Now this is rewritten. 2 into 10 gives me 20, right? So 20 pi over 3 with the cos value positive I times sine of 20 pi over 3. The theta will remain the same here also. We don't have to do anything. So this is the polar form. This is actually square root of 2 times I, and we are expected to evaluate this. So what I wish to do is let z be equal to 2 times I. Now this would mean we know that z is of the form x positive iy is equal to 2 times I. So this means x is equal to 0 and y is equal to 2. Okay, now any complex number can be written in polar form as z is equal to r times of cos theta positive I times sin theta, right? This is the polar form where r is equal to root of x squared positive y squared. So I'm calculating r, this is 0 squared positive y 2 raised to the power of 2, which is nothing but 2. So my value of r is obtained. So also if I were to get the value for tan theta, my tan theta is going to be equal to y divided by x. Now there is something that we need to look into this part. Now to get the value of theta, we cannot use this for the simple fact that y is 2 and x is 0. So we are basically hitting the wall. But what we can do is we can actually use the definition of polar coordinates. When we started with, we had x to be equal to r times cos theta and y to be equal to r times sin theta. Now we will be using this one. Since r, or I should write it like this, since r is equal to 2, I can rewrite this as x is equal to 2 times cos theta. But x is equal to 0, right? So this would mean 2 times cos theta is equal to 0, which in turn means cos theta is equal to 0, right? Now when is cos theta is equal to 0? when theta is equal to 90 degrees, or when theta is equal to pi over 2. Right, pi over 2 or theta is equal to 90 degrees. So clearly we have obtained the value of theta. So therefore the complex number z is equal to r times 2 times cos of 90 degrees positive I times sine of 90 degrees. So this is what we have got. But this is not what we want. We are asked to find the root of 2 times I. So how are you going to do that? So therefore square root, because z is equal to 2i, z is equal to 2i, so square root of z is nothing but square root of 2i, which is nothing but my z is this, right? So square root of 2 times of cos 90 positive I times of sine 90. So what is this? This is nothing but 2 times cos 90 positive I times sine 90. This 2 is over here and it is raised to the power of 1 over 2. By De Moivre's theorem, this is nothing but 2 raised to the power of 1 over 2 times cos of 1 over 2 times 90 positive I times sine of 1 over 2 times 90, which is nothing but 2 raised to the power of 1 over 2 of cos 45 degrees positive I times sine 45 degrees. So what is cos 45? Cos 45 is 1 over root 2. And what is sine 45? 1 over root 2. So I can take root 2 as the LCM. If I were to take root 2 as the LCM, of course there is a 2 raised to the power 1 over 2, which is nothing but root 2. If I were to take root 2 as the LCM, I will get 1 positive I. Now root 2 gets cancelled. So what do I have? I got 1 positive I. Now what is this? This is nothing but root of 2 times I. That is the solution for this question. It's a lovely question, students, and this is a good place for us to stop. Thank you. Welcome everybody. In this class we will be learning about inverse trigonometric functions. So the first and foremost question that we would have to ask and understand is, when can a function have an inverse? This is a very important question. When can a function have an inverse? The necessary condition, or I should say the necessary and sufficient condition for a function to have an inverse is that the function should be bijective. This is the necessary and sufficient condition. So once you check this condition, and if it is true, then the function is said to have an inverse. So next question comes is, what exactly is the meaning of bijective? So that's exactly what I'm going to define here. So let me write that down. A function is said to be bijective. A function is said to be bijective if it is both injective and surjective. Very important keywords: injective, surjective. Now, what is the meaning of being injective? When is a function said to be injective? This is a question. Answer: a function is said to be injective if it is 1 to 1. So we either write it like this or we write it like this, 1 to 1. So what is the meaning of 1 to 1? Now suppose you have a function, say f of a going on to b. We call this as domain. A is said to be domain and b is called the codomain. Now let me give you this illustration for injective. Now in A, this is set A and this is set B. So you got elements like A, B and C. And in set B, you got elements like D, E, F and G. Now if every element in A has a unique element in B, say A goes to B, A goes to D, B goes to E and C goes to G. It doesn't matter, C goes to F. It doesn't matter if G is left out, right? But the condition is every X element of A should be mapped to a unique element in B. Okay, so this is the meaning of 1 to 1. So that is the important understanding that you should have with regard to the concept of injective. So having given you that injective concept, let's move on. Now let me give an illustration to reinforce the concept of injective. Now let me have a mapping of a function from A to B such that A and B are set of real numbers. And let me ask you this question. Say f of x is equal to 3x squared positive 2. The question is this function injective? Okay, that's the question I wanted to ask. So what is the definition for injective? For every x element of A, there should exist some y element of B such that f of x is equal to that y. So this understanding should be present in the definition. Now what is the exact meaning of this? It means suppose you got x1 and x2 element of A. Now if you are checking for the function to be injective, f of x1 cannot be mapped to y with f of x2 also being mapped to y. This is a clearly no, right? So in this case, what are we trying to show here? We are trying to show here that two elements from A, this is A, x1 and x2, this is B, is mapped to a single element, or I should say to the same element y in B. So this is not injective. The condition fails. So as I mentioned to you, if I were to take this f of x is equal to 3x squared positive 2, is this, I asked you this question, is this function injective? So if I were to take x being equal to positive 2 and x being equal to negative 2, okay, f of x in this case, f of 2 will be 3 of 2 squared positive 2. This is 4, 3, 12 positive 2 gives me 410, and f of negative 2 is 3 of negative 2 squared positive 2, which is also going to be equal to 14. So two elements from A, 2 and minus 2 is being mapped to a single element, the same element 14 in B. So this would mean f of x is equal to 3x squared positive 2 is not injective. So once this condition fails, f of x is not bijective. So what does it mean? This means f of x cannot have an inverse. Cannot have an inverse. So mathematically we can say function, you can state it like this: inverse does not exist for the function. Okay, that's a better way to say inverse does not exist for the function. So the first condition fails, right? So having given you the definition of injective, let us move on to understanding surjective. So let me just reiterate one more time. If you want to check the function for injective, simple concept is it should be 1 to 1. That's it. So you look for this in the function. And having mentioned this, let us understand what is surjective. So when is a function said to be surjective? That's a question. When is a function said to be surjective? Now what is the meaning of surjective? Surjective means onto. So what is the understanding of onto? Let me state it here. If every element present in the codomain is mapped to by at least one element in the domain, then the function is said to be surjective. It's also called as surjection, and we can also call it to be as onto. So example, I got A, I got B, and we have a mapping going on from A to B. Elements in A are A, B, C, D. Elements in B are 1, 2, 3, 4. A goes to 1, B goes to 2, 3 and 4. Now every element, this is the codomain. Every element in the codomain is being mapped by at least one element in the domain. Now you have to understand, just because a function is surjective, it doesn't mean it's going to be injective. So that is an important note. Function being surjective does not imply that the function is also, in fact, will be also, you can substitute, injective, right? So don't assume that. So this assumption is dangerous, okay? So make a point of it. And on the contrary, vice versa also is true. So just because the function is injective, it will not automatically qualify to be surjective. So those are important points. Now to briefly state is, this line of statement would be sufficient. So if you want to check for onto, the codomain should be equal to the range of the function. So you will have to understand one important concept. Say for example, the concept of codomain and range. Now if you have a function, say R going on to R, and you have f of x to be equal to, say, sine x, right? the range of this function lying between -1 less than equal to x less than equal to +1. So this is the range of the function. Now this range and this functional mapping R to R is totally different. So this one is the reach of the function, whereas this one is called the codomain of the function. So the function can take any values in R. So there is a saying in the English language, the sky is the limit. Sky is the limit. The sky is the limit, but every individual has a limit. So what is the limit of an individual? That is what we call it as range. But sky is the limit, right? So you have to have those two things in perspective. So having given you this illustration for surjective, let me concurrently give you an example for a function which isn't surjective. Say for example you got A, B and C, and you got 1, 2, 3, 4. Say you got A going on to 1 and B going on to 2 and C going on to say 3. In this case 4 is left out. So this is not surjective. So you cannot leave any element on the codomain. Even one element is left out, the condition fails. Now, having mentioned all of this, let us come to inverse trigonometry functions. So far we have just discussed when a function can have inverse. So there is another word for inverse. We use it as invertible. So once the function is bijective, we call the function to be invertible. So the meaning is the function can have an inverse. Is it necessary that all functions should have an inverse? No. All function cannot, as you have just seen, have an inverse. Two conditions are imperative, surjective and injective. So both these conditions, in fact I should start with injective and surjective. The function has to be 1 to 1 and then on to. So both these conditions have to be satisfied. So this is injective and this is surjective. Only then the function qualifies to have an inverse. Now how do we find an inverse? Simple. I can show you how exactly to find an inverse. Okay, so before I could go on to show you how to find an inverse, we are so far dealing only algebraically. We have not gone into the trigonometric part. So I will slowly head on to the trigonometric part. As I mentioned to you, I've just asked you a question, is f of x equal to sine x, is it bijective? So I'm asking you, is it 1 to 1 onto? So I will answer the question within a minute. So what I'm going to show you is, I'm going to show you how exactly to find an inverse for this function. F of x is equal to 2x positive 1. Now this is the function that is given. Now if I were to take, if the function is defined from R to R, now clearly just by observation you can see that this function is bijective. So once it's bijective, it will have an inverse. So what I wish to do is I would like to start off by writing like this: y is equal to 2x positive 1. Then what do you have to do is replace all x by y and vice versa. So if you see an x, you replace it by y. If you see a y, you replace it by x. So in this case, it's going to be x is equal to 2 times y positive 1. Then step 2, you rewrite the equation for y. So in other words, what I'm trying to tell you here is y should be on the left hand side. So for that, move 1 to the other side, you get 2y. So from here, therefore 2y is equal to x negative 1. This implies y is equal to x negative 1 over 2. So this is the inverse. So this means when you're writing, you write it like this: f inverse of x is equal to x negative 1 over 2. So I've got this. Now how do you check if this is the inverse? F composition f inverse of x should be equal to f inverse composition f of x should give you x. So let's check this out. So we have f of x. This is given. F of x is equal to 2x positive 1. F inverse of x is x negative 1 over 2. So consider f composition f inverse of x is nothing but f of f inverse of x, right, which is nothing but you have to substitute f inverse of x into the function. So what is f of x? F of x is this. So 2 times of, in place of x I substitute x negative 1 over 2, right, followed by positive 1. So this is going to be x negative 1 positive 1, which is equal to x. So we have got this x, you see that. So also consider f inverse composition f of x. Now what is this is equal to? This is equal to f inverse of f of x, which is nothing but, you'll have to substitute f of x inside x minus 1, so over 2. That is going to be 2x positive 1 negative 1 divided by 2. Positive 1 negative 1 gets cancelled, giving you 2x over 2 is equal to x. So this means f composition f inverse of x is equal to f inverse composition f of x is equal to x. So this means f and f inverse are inverses to each other. You don't have to state it, it's understood, right? So we have proved it that f inverse is indeed the inverse, or you can say that this means f inverse of x is indeed the inverse of f of x. So that is all about the algebraic part of it. So now the question comes is, what would be the situation if the function doesn't have an inverse? If the inverse does not exist for a function. Now there is a technique. That is exactly what we are going to apply for trigonometric functions. So having mentioned this, let us go on to understand the inverse functions from trigonometric point of view. So as I mentioned to you, the very first question is sin x bijective? That's the simple question I'm asking. Is sin x bijective? So make your choices. Is it bijective or is it not a bijective function? Can I say sin x is a bijective function, or can I say inverse exists for sin x? So if you would have made your decision, is it a yes or no, then we can move on in understanding the concepts in trigonometric perspective. So question, let me state it here. Is f of x is equal to sin x bijective? Now how are we to check for this? Let me draw the graph of sin x. So the graph is like this, it's in waveform. Now there is something called as the horizontal line test. Horizontal line test. So what exactly does it mean? Just draw an horizontal line. Now if this line cuts the curve at exactly at one point, then the function is bijective. Now if you were to see this, if you take this particular point and you're drawing a line, the horizontal line cutting the curve at this point, this point, this point, this point, this point, and this point, and so on. Infinite number of places the line is cutting the curve. But according to the definition, a function is bijective if it has to be, if it is injective and subsequently surjective. But in this case, the test for injection fails. The function isn't injective. You see that you take one particular point and you're drawing a line. That one particular point is cutting the curve at infinitely many points. So the horizontal line test fails. So the conclusion here is, if the horizontal line test fails, that would mean f of x is equal to sin x is not bijective. If a function is not bijective, then inverse doesn't exist. Now, when a function is not having an inverse, but we got an entire topic called as inverse trigonometric function, because if it's going to be failing for sin x, naturally none of the trigonometrical ratios will satisfy, because sin x is the parent, almost like a bulwark in trigonometric identities and trigonometric ratios, because everything starts with sine. And if the test is failing for sin x, then undoubtedly an element of evidence for us to state that the test would not be satisfied by other trigonometric ratios. So that's the entire idea I'm trying to infer here. If that be the state here, then what are we doing with this particular topic? Well, the answer lies in this particular unique concept called as restriction of the domain. See, in this case, there is no restriction, okay? The sin x is heading from point 0, it moves up to the right side. It will also do the same thing on the left hand side. And in this case, say for example, the wave, this is going to be hitting the point at 2 pi and so on and so forth. It is going to be the same. The pattern is going to be repeating infinite number of times, and this line is going to be hitting the curve at infinite many points. So what is the only probability or the only opportunity we got in showing that f of x is equal to sin x as an inverse, or f of x is equal to sin x is bijective, is by the concept of what is called as restriction of the domain. So what am I talking about? So I'm talking here about let us restrict the domain, okay, to negative pi over 2 to positive pi over 2. That is the secret. So how am I going to do that? Because in this case there is no restriction. But if I were to place a restriction, let me show you that restriction. So the curve, see that? I'm just going to, this point is positive 1. This point is negative 1. The sin x curve hits the point, it's the maximum here at 1, and it hits the lowest point at negative 1. So instead of moving up to 2 pi and 4 pi and 6 pi and 8 pi and so on and so forth, I want to put an end at pi over 2. The function hits 1. So this is the point the function hits. And similarly at negative pi over 2, the function hits negative 1. So this is the point. So let me just draw this. So this is what we are going to do. And what you call such a function, this is sine function, right? But this is called as the principal sine function. So that's a technical term. So what exactly happens in the principal sine function? The domain is restricted between negative pi over 2 to positive pi over 2. So in this case, if you were to draw the horizontal line, if you were to perform the horizontal line test, right? So I take this horizontal line and I hit it. There will be just one point of intersection. This is exactly what we want. No matter where you draw this horizontal line, it will cut the curve at exactly one point. And that is what is required in proving that the function is bijective. So in general, to sum up, f of x is equal to sin x. Okay, let me write that. In general, sin x, let me write it like this, f of x is equal to sin x is not bijective. But with the restriction of domain, principal sine function is bijective. So that is the important part you will have to know. So in this case, I think we can now head on in understanding the inverse trigonometric functions. So that would be a good place for us to stop and wrap up this fundamental discussions about function being invertible. Now the next important concept is, how do we represent these functions? How do we represent the function? Right? So f of x is equal to sin x with restrictive domain. So we are talking about the principal sine function. In this case, f is heading from negative pi over 2 to positive pi over 2. right? And the maximum value is positive 1, minimum value is negative 1. So we always start with the minimum value and place the maximum value. So this is the representation for the principal sine function. Now, having got this, let us give the representation for the inverse function. So f inverse of x, we have already found that is represented as sine inverse of x. So when I say we have already found that, so in this case we already know that principal sine function as an inverse, and this is how we make the representation. F inverse of x is equal to sine inverse of x. And how do we give the mapping? It is given as follows: f inverse. Now over here f is actually heading from negative pi over 2 comma pi over 2 to negative 1 comma 1. So for f inverse it would be the exact reverse. So it will start with negative 1 comma 1 and it will head on to negative pi over 2 to pi over 2. Now one important part, whenever we are talking about inverses, we do not use the term codomain, because for the function, in particular inverse functions, a function can only have an inverse if the codomain is equal to range. So whenever we are talking about the codomain, we mean that the codomain is equal to the range, and only then the function can become onto. So that is an important part or important point you will have to know. So when we are usually referring to inverse functions, we will only talk about domain and range. We will not use this term codomain, because codomain required to be equal to the range. Only then we can clearly say that the function has an inverse. So since we have already shown that, so there is no reason for us to be utilizing or using the term codomain, right? So from here onwards we will only be referring to the right side as range, right? So having made that clear, let us move on. Now let us write down the properties of sine inverse of x. Right, now foremost we need to draw the graph of sine inverse of x. Now clearly you can see the sine x graph is actually moving up like this. Now to get the sine inverse x graph, you will have to reflect this onto the line y is equal to x. If you were to do that, you will be able to obtain the sine inverse x graph. So how does the graph look? Now instead of opening down, the graph is going to be opening up, and it will be flowing like this. So this is going to be the sine inverse of x graph. So what would be the domain? So the domain in this case, so let me write that down. The domain for sine inverse of x is going to be from negative 1 to positive 1. And next is range. The range is, so this is going to be negative 1 and this is going to be positive 1. That's important, right? So the range is going to be negative pi over 2 to pi over 2. So as I mentioned to you, range is indeed the codomain here. And clearly you can see the graph is continuous. It is continuous. And it is also differentiable. And it is periodic. And it is 1 to 1. And it is onto. So I have listed 1, 2, 3, 4, 5, 6 and 7 points. So this is in connection with sine inverse of x. So you have to remember all of these things. Now the next important question is f inverse of x is equal to sine inverse of x? Is the function symmetric? answer this. Is it symmetric or not? Now, how are you going to find if a function is symmetric or not? Now, the simplest way is go to the origin. From the origin, you draw a line. You get a point. Now, from the same origin, subsequently to the same distance, you draw another line and you get another point. Now, if you're able to do this from the origin, you can clearly say the function is symmetric. This implies the function is symmetric about the origin, right? Because from the origin you're moving up, you're getting a point. From the same origin you're moving down, you're getting another point. So if you were to able to connect this, clearly you can, with concrete definiteness, you can say that the function is symmetric about the origin. Now, subsequently, so let me write that down. Point number 8, the function is symmetric about origin. And point number 9, once the function is symmetric about the origin, the function is called as an odd function. So the requirement for a function to be odd is the function has to be symmetric about the origin. And once it is symmetric about the origin, the function is an odd function. So those are some of the important critical informations that we will have to know with regard to sine inverse of x. Now, since I've given you 9 points, let me also give the 10th one. The question is the function increasing and is the function bounded? Now clearly, if you were to be heading from the origin up, if the function is indeed increasing, and you can clearly see the range is actually negative pi over 2 comma pi over 2. So the 10th point is the function is increasing and it is bounded. And it is bounded. Okay, so 10 important points we have given for sine inverse of x. Now likewise, we can also give these important points for other inverse functions like secant inverse of x, cosecant inverse of x, cos inverse of x, tan inverse of x, cotan inverse of x. Now it becomes necessary that we know all of these graphs. Now foremost, I'm going to teach you a technique by which you can with ease draw all of these inverse trigonometric functions graphs. Now foremost, let us start with cosecant inverse of x. Now what is cosecant x? Cosecant x is the reciprocal of sine x. Now just make the observation for sine x graph. Now the graph is in this fashion. Now how are we going to draw the cosecant x inverse graph? Now wherever the function ends, the cosecant x inverse starts. So in this case it ends here. So if you were to draw the graph, let me show you over here how to draw this graph. Right. So clearly you can see the sine x graph ends at this point. So wherever it is ending, you start the cosecant x graph from there. So this is ending here. So from here I'm starting cosecant x and you move up like that. That's it. Now it ends here. So from here you move out like that. So what is this? With ease we have got cosecant inverse of x graph with ease, right? Of course these points would be 2 and 4 and so on and so forth. So it will be moving up to plus infinity on the right side, and this is going to be negative 2, negative 4, moving all the way to negative infinity, right? And this point is 0. So on the right side cosecant inverse of x is heading towards positive infinity. On the left side it's heading towards negative infinity. So this is the method for drawing cosecant inverse of x. So let's also see how to draw cos inverse of x and secant inverse of x. Now let's look into the graph of cos inverse. So the graph of cos inverse of x looks in this fashion. So let me draw that. So the graph is going to be heading down. If this point is 1 and this is 2, it will move up and down like this, and this is going to be 1. So this is the graph of cos inverse of x. Now, having drawn the graph of cos inverse of x, we will have to draw the graph of y is equal to secant inverse of x. Now, how do we draw that? Let me show you that. Now, wherever the graph ends for cos inverse of x, secant inverse of x begins. So it is ending over here. So what you do is start from here and move down. Now similarly, it is ending over here. This point is 1, right? Now from here you move up. So there is actually an asymptote here. So this is going to be the graph of secant inverse of x, and it looks really beautiful. So we've got the graph for cos inverse of x, secant inverse of x, cosecant inverse of x, sine inverse of x, and all it remains is tan inverse of x and cot tan inverse of x. The last two remaining graphs are y is equal to tan inverse of x. So let me draw this graph. Y is equal to tan inverse of x. So the graph will look something of this fashion. And it will actually go down like this. So this point which you see here and this point it doesn't touch here, right? It's an asymptote. This is going to be plus pi over 2 and this is negative pi over 2. So this is for tan inverse of x. Now let me show you cot inverse of x. How does that look? Now tan inverse of x goes like this. Cot inverse of x will go like the exact opposite side. So let me draw that. So the graph would be hitting the point like that and moving down like this. So we will have to draw the asymptotes. Okay, so this point is going to be pi. Now one important observation is that it doesn't come to the negative side. So this is 4 and this is 5. The graph will never come to the negative end. So that would mean cot inverse of x is always positive. So it's always on the upper half. So that's an observation. But in this case it's not so. It comes down, right? So have that in mind. So having given these graphs, it's time for us to start problem solving. Now the very next important concepts that we have to look in with regard to inverse functions is the concept of domain and range. Now many of the questions are focused on this particular concept, domain and range. So foremost, let me just write down the heading, the function and its domain and its range. So To start off with, the function is y is equal to sine inverse of x, function 1. Its domain is between -1 less than equal to x less than equal to 1, and its range is -pi/2 less than equal to y less than equal to +pi/2. That's the first thing. So next is obviously y is equal to cos inverse of x, and its domain is -1 less than equal to x less than equal to 1, and the range is 0 less than equal to y less than equal to pi. So it's a positive function. So when I say positive, it doesn't come down to the other half, the negative end, right? So moving on, y is equal to tan inverse of x. The domain is all x element of real number, and the range is pi/2 strictly less than y, strictly less than pi/2. So this -pi/2 strictly less than y less than pi/2. So you can clearly see that from the graph. So all of these concepts which I am just placing here are clearly observant from the very graph which I have just shown you a few minutes ago. So moving on, for y is equal to cot inverse of x. In cot inverse of x, it's all x element of real number, and it is strictly on the positive side. As I mentioned to you from the graph, it doesn't come down at all. So that's the graph for cot inverse, or I should say the range for cot inverse of x. So 5, y is equal to cosecant inverse of x. This is all x less than equal to -1, or all x greater than equal to +1. This is clearly observant from the graph. And the range is going to be -pi/2 less than equal to y less than equal to pi/2, and y is never equal to 0. Number 6, y is equal to secant inverse of x. This is x less than equal to -1 or x greater than equal to 1, and the value is 0 less than equal to y less than equal to pi, and y is never equal to pi/2. So that's for secant inverse of x. So clearly from the range you can clearly find out if the function is increasing or decreasing. So having given you all this, we will head on. Now when it comes to remembering the range for these functions, it is sufficient that you remember the following groups. So sine inverse of x, tan inverse of x, and cosecant inverse of x, they all are present in one group. So how am I going to remember it? Now sine inverse of x, it's well known fact that the range is between -pi/2 and pi/2, right? Now for tan inverse of x, now this is closed interval, right? For tan inverse of x, the interval becomes open. So this is completely closed, this is open. Now when you come to cosecant inverse of x, cosecant inverse of x is nothing but the reciprocal for sine. Cosecant is the reciprocal for sine, right? So cosecant inverse of x will have something similar to the sine inverse of x. So that is the reason that the range is between -pi/2 and pi/2. But apparently y is not equal to 0 here. So have that in mind. So sine inverse of x, tan inverse of x, and cosecant inverse of x, they all fall in one group. And we start with closed interval, and then an open interval, and then again a closed interval, with one exception that y is not equal to 0. Now coming to the cos inverse of x. Now as I mentioned to you, the only other remaining group is cos inverse of x, cot inverse of x, and secant inverse of x. Secant inverse of x is the reciprocal for cos inverse of x. So there will be a similarity. Now cos inverse of x, in this case it starts with negative pi over 2 and pi over 2. But cos inverse of x is between 0 and pi, and it is closed interval. So cot inverse of x is going to be open. You follow me? This is 0 less than equal to y less than equal to pi. This is going to be 0 strictly less than y strictly less than pi. And the secant inverse of x is exactly going to be what you got for cos inverse, with one exception, that y cannot be equal to pi over 2. That is the only exception that is placed in secant inverse of x. So this is a good technique, and you will never forget this if you are going to be using the strategies that I'm just showing you here. You will never forget the range of these inverse trigonometric functions at all. Let's do this question, students. The question is as follows. Let f of x be equal to cos of 2 times tan inverse of sine of cot inverse of square root of 1 negative x divided by x. It is a parenthesis here. And so this is for this, and you got a parenthesis here, and then you got another parenthesis. So this is given, and you're also given that x is lying between 0 and 1. Then the choice are, is it 1 negative x raised to the power of 2 times f dash of x negative 2 times f of x raised to the power of 2 is equal to 0. Which of these equations will be true? That's the requirement for this question. So 1 positive x raised to the power of 2 f dash of x positive 2 times of f of x raised to the power of 2 is equal to 0. And then C is 1 negative x raised to the power of 2 f dash of x positive 2 times f of x raised to the power of 2 is equal to 0. Or D, 1 positive x raised to the power of 2 f dash of x negative 2 times f of x raised to the power of 2 is equal to 0. So which of these equations is said to be true if the function is given in this fashion? So having given you this question, let's move on to the next page and work out the solution. So foremost, let us consider the given question. So let me write that down here. Consider f of x being equal to cos of 2 times tan inverse of sine of cot inverse of root of 1 negative x over x. Right, this is given. So what I wish to do is, I would like to now take cot inverse of root of 1 negative x over x to be equal to some theta. So this would mean cot theta is equal to root of 1 negative x divided by root of x. So if I were to use the trigonometric laws, this is my theta, this is cot theta. Cot theta is adjacent over opposite. So this is going to be root of 1 negative x, and this is going to be root of x. Right, now if you want to get the hypotenuse, you can very well do that. So hypotenuse is equal to, if I were to take this as a, b and c, ab squared positive bc squared is ac squared. You square it, you get 1 negative x. You square it, you get x, and this is ac squared, so therefore ac is equal to 1. So this is going to be 1. Now if you were to find sine theta. Sine theta is equal to root of x divided by 1, which is nothing but root of x. So this is my sine theta. Now you might be wondering, why did I take sine theta? Now if you were to take this as 1, therefore 1 can be rewritten as f of x is equal to cos of 2 times tan inverse of sine of. Now cot inverse of this entire quantity is taken to be as sine theta. So this is my, in fact it's taken as theta. So this is going to be producing theta. So this is sine theta, and I've got a parenthesis. You don't have to place parenthesis, just for the sake of some level of identification. So this is equal to cos of 2 times of tan inverse of. Now what is sine theta? Sine theta is going to be root x. So this is root x. So now what I've got cos of 2 times of tan inverse of root x. Right? This is my f of x. So now what I'm going to do is I want to let tan inverse of root x be equal to some phi. So this would mean tan phi is equal to root x. Right? So if I were to substitute this is going to be equal to cot 2 times of tan inverse of root x is equal to phi. So this is going to be phi. So I have f of x to be equal to cos 2 phi. Now if I were to rewrite this in terms of tan, this is going to be 1 negative. We have already seen this formula, 1 negative tan squared phi divided by 1 positive tan squared phi. But what is tan phi? Tan phi is nothing but root x. So 1 negative root x raised to the power of 2 divided by 1 positive root x raised to the power of 2, which is nothing but 1 negative x divided by 1 positive x, which is my f of x. So therefore f of x is equal to 1 negative x divided by 1 positive x. This is my f of x. Now I need to find out f dash of x. Why? Because the choice involves f dash of x. So f dash of x is equal to u over v differentiation. So 1 positive x times the differential of 1 negative x is negative 1. Negative 1 negative x times the differential of 1 positive x is 1 divided by 1 positive x raised to the power of 2. This is going to be negative 1 negative x negative 1 positive x divided by 1 positive x raised to the power of 2. Positive x negative x gets cancelled, giving me negative 2 over 1 positive x raised to the power of 2. So this is my f dash of x. Now what I wish to do is I will have to get a f of x square, because in the output, in the choices, every quantity has got an f of x. But f of x, what is f of x? F of x is 1 negative x divided by 1 positive x. But as I mentioned to you, all of the choices have got f of x raised to the power of 2. So what I would like to do, I would like to rewrite this as negative 2 divided by 1 positive x. Right? So there is already a square there. So I don't have to do anything for the denominator, but I will have to bring this term here. So I'm multiplying it by 1 negative x raised to the power of 2. If I were to do that, subsequently I will have to multiply the left hand side by 1 negative x raised to the power of 2. Right? So rewriting, if I were to rewrite this, this is going to be equal to negative 2 times, I can write this as 1 negative x divided by 1 positive x raised to the power of 2. But what is this? This is nothing but f of x. So this is equal to negative 2 times f of x raised to the power of 2. And on the left side I get 1 negative x raised to the power of 2 into f dash of x. Now I move this to the left hand side, I get 1 negative x raised to the power of 2 times f dash of x positive 2 times f of x raised to the power of 2 is equal to 0. So this is what I've got. Now you have to go and check back the choices. So let me show you this choice. So before I could flip the page and move to the previous page, just make sure that this is written at the corner of your mind. 1 negative x raised to the power of 2, f dash of x positive 2 times f of x raised to the power of 2 is equal to 0. So this is the choice we are looking for. So now clearly you can see that 1 negative x raised to the power of 2 times f dash of x positive 2 times f of x raised to the power of 2. This is the only thing that is available, which corresponds to our required output that we just received. So C is the answer. A cannot be the answer because it's negative here, but this is our solution. So having got that, we'll move on to the next question. The question is a possible value of tan of 1 over 4 sine inverse of root of 63 over 8 is, this is what is asked. Right now you've been given list of choices. One is 1 over 2 times root 2, 1 over root 7, root 7 negative 1, and 2 times root 2 negative 1. So these are the choices that have been given. So how are we going to do this question? So foremost, let me just take sine inverse of root of 63 over 8 to be equal to theta. So this would mean my sine theta is root of 63 divided by 8. So if I were to draw the right triangle, this is theta, opposite side is 63 with the square root, hypotenuse is 8. If I were to take this as ABC, AB squared positive BC squared is AC squared. AB squared I don't know. BC squared is 63, AC squared is 64. So AB squared is 64 negative 63, which is 1. So AB is equal to 1. So this is 1 unit. So sine theta is 1 unit. So therefore, let me write down cos. Cos theta is going to be 1 over 8. This is a beautiful value. So if I were to take this as 1, therefore I can rewrite 1 as tan of 1 over 4. Now sine inverse of this quantity, that's going to be equal to theta. So this is going to be 1 over 4 theta. So we are actually trying to get tan of theta over 4. A very unique result that is required for this question. Now what I wish to do is I would like to connect a formula. What is the formula? Square root of 1 negative cos x divided by 1 positive cos x. What is this equal to? This is equal to root of 2 times sine squared x over 2 divided by root of cos squared x over 2, which is nothing but sine x over 2 divided by cos x over 2, which is nothing but tan x over 2. So this is the formula we have. Tan x over 2 is root of 1 negative cos x divided by 1 positive cos x. Right? But we wanted tan theta over 4. So clearly if you were to compare this with this, over here you got x over 2, over here we got x. So that means the angle gets doubled. So therefore I wish to write tan theta over 4 to be equal to root of 1 negative cos theta over 2 divided by 1 positive cos theta over 2, right? Now we got cos theta is equal to 1 over 8. So we will have to extract cos theta over 2. So let me give you this formula. Now we know that I'm using the variable t because I don't want to use theta. Now cos 2 theta is nothing but 2 times cos square theta negative 1, right? Now if I were to take 2 theta to be equal to 2t to be equal to theta, then this is going to be cos of theta is equal to 2 times cos squared t is going to be theta over 2 negative 1, right? So I've got a beautiful formula which I can use. So that is exactly what I'm going to do. So from here, I'm going to use the space here. So from here, I got cos theta positive 1 is equal to 2 times cos squared theta over 2, which would mean cos theta positive 1 divided by 2 is equal to cos squared theta over 2. I need only cos theta over 2, so therefore cos theta over 2 is equal to root of cos theta positive 1 divided by 2. But I know cos theta. Cos theta is 1 over 8. So I substitute that value. So this is equal to root of 1 over 8 positive 1 divided by 2. So which is equal to 8 added with 1, that's going to be 9 over 8 multiplied with 2, right? When you flip it, you're going to get 1 over 2, that's going to be 16. So this is the root value for this, which is nothing but 3 over 4. So this is my cos theta over 2. So take this value and substitute it here. So this is equal to root of 1 negative 3 over 4 divided by 1 positive 3 over 4. This is equal to root of 4 negative 3, that's 1 over 4 divided by 4 with 3, that's going to be 7 over 4. So you flip this, this is equal to 1 over 4 times 4 over 7, which is going to be root of 1 over 7, right? 4 gets cancelled, 1 over 7, which I can rewrite it as 1 over root 7. So what is this value? This value is nothing but tan of 1 over 4 of sine inverse of root of 63 divided by 8, right? So this is 1 over root 7. So let's go to the choice. So if you were to go to the choice, you will clearly see that B is the right answer. So let me tick that. So that is the solution for this question, students. It's a lovely question. We will move on to the next one. Question is given as follows. If 0 less than x less than 1, then root of 1 positive x squared of x times cos of cot inverse of x positive sine of cot inverse of x. This entire thing is raised to the power of 2 followed by negative 1, and that is raised to the power of 1 over 2 is equal to what? This is required, right? Now there are a list of choices, so probably I will place in those choices. So choice number 1, is it x over root of 1 positive x squared? Choice 2, is it x? 3, is it x times root of 1 positive x squared? Choice D, is it root of 1 positive x squared? So you got 4 choices. So let's get the solution. So foremost, if you can see this question, the question as cot inverse of x, right? So solution, I'm going to start it in this fashion. Let cot inverse of x be equal to theta. So this would mean cot theta is equal to x. I'm going to write it as x over 1. So if I were to draw the right triangle, cot theta is adjacent over opposite. So this is going to be x and 1. Of course this is theta. If I were to take this as a, b and c, I want to find AC. So AB squared positive BC squared is equal to AC squared. AB squared is x squared, BC squared is 1. So therefore AC is equal to root of 1 positive x squared. So this is going to be root of 1 positive x squared. So we got that. So having got that, if I were to take this as 1, so I can rewrite 1 can be rewritten as root of 1 positive x squared times x times cot inverse of x is taken as theta. This is theta there, positive, right, sine of cot inverse of x is theta, and this is raised to the power of 2 followed by negative 1, and that in turn is raised to the power of 1 over 2. So this is what we've got. So now from here I can get cos theta. Now what is cos theta here? From here, cos theta is equal to x over root of 1 positive x squared, that is cos, and what is sine? Sine theta is equal to 1 over root of 1 positive x squared. So if we were to replace that in the given function or in the given expression, that would give me root of 1 positive x squared of x times, now cos is x over root of 1 positive x squared, positive sine is 1 over root of 1 positive x squared, right, and this is raised to the power of 2 followed by a negative 1, that is raised to the power of 1 over 2. This is equal to root of 1 positive x squared. Now if I were to take the LCM as root of 1 positive x squared, and that would give me x squared positive 1, right, this is raised to the power of 2 followed by a negative 1, and this is raised to the power of half. So this is actually x squared positive 1 divided by root of 1 positive x squared. So can I not write this as root of 1 positive x squared? This is raised to the power of 2 followed by a negative 1 raised to the power of 1 over 2. Can I not do that? Now square root and square, they both get cancelled, giving me root of 1 positive x squared. This is going to be 1 positive x squared negative 1, and that is raised to the power of 1 over 2, right? Positive 1 and negative 1 can be cancelled, and that is going to give me x squared raised to the power of 1 over 2. What is that? Square root of x squared will give me x. So the solution is going to be x times root of 1 positive x squared, and we have to look for this value. So where is it? Clearly our focus goes on to this choice, right? X times root of 1 positive x squared. So this is the correct choice for this question. So that is the end of the solution, students. We will move on to the next one. Welcome, students. In this particular chapter we will deal with questions that are connected to domain and range. So we got the first question: find the domain of f of x such that f of x is given to be equal to sine inverse of x negative 3 divided by 2 followed by a negative sign log of 4 negative x to the base 10. Now we know that this is the solution. We know that the domain for f of x equal to sine inverse of x is lying between negative 1 less than equal to x less than equal to 1, and the domain for log is actually greater than 0, right? It's only positive values that can be affected by log. So knowing these two information, let us now place in the given quantity. So from the question, we know that x negative 3 over 2 is less than equal to negative 1, and on this side it's greater than equal to negative 1 and less than equal to positive 1. So this is the region, right? Now what I wish to do is I would like to get rid of this 2. So I would multiply by 2. This would give me negative 2 less than equal to x negative 3 less than equal to 2. Now I would like to get rid of this negative 3. So I add positive 3, positive 3, positive 3. So that in turn would give me negative 2 added with positive 3 is going to be positive 1 less than equal to x less than equal to 5, right? So this is obtained. Now let us head to log. As I mentioned to you, this is only possible if 4 negative x is greater than 0. Now if I were to move x to the other side, I would get 4 is greater than x. In other words, I can also rewrite this as x is less than 4. Now you got two regions. Let me just draw the number line. This is 0, 1, 2, 3, 4, 5, and for the first set, for this x, this is going to be the region, right? But we will have to take the composition of this with this. Now x less than 4. X less than 4 is all values that are lying below 4. So this would be the point. So from here to there, right? But the only point that we have to note here is this is an open interval. So therefore when we are writing, therefore the solution is closed interval 1 comma open interval 4. Now there were 4 choices given for this question. Choice 1 is it between 1 comma 5. So they are asking us to find the domain, right? Find the domain. So they have given it as an MCQ. And choice 2 is 1 comma 4 with the other end being open. And the other one is 1 comma 4. The final one is 1 comma 4. Right? This is open interval. So clearly we can easily see that choice B is the right solution, right? So we will move on to the next question, and let's see the question. So we are expected to find the domain of the function cosecant inverse of 1 positive x divided by x. So we are being given the following choices. So A, negative 1 comma 1 over 2, of course there's a negative sign there, union 0 comma infinity, choice A. Choice B, negative 1 over 2 comma 0 union 1 comma infinity, and choice C, negative 1 comma 2 comma infinity negative 0, and choice D is negative 1 over 2 comma infinity negative 0, right? Now we have to make the following observation for the solution. Now if f of x is equal to cosecant inverse of x, then the domain is given to be as all x less than equal to negative 1 or all x greater than or equal to positive 1. So either this or this. So we are being given cosecant inverse of 1 positive x divided by x. Okay, now consider f of x is equal to cosecant inverse of 1 positive x over x. So this would mean 1 positive x over x is less than or equal to negative 1, or 1 positive x over x is greater than or equal to 1. Right? So from here, if I were to move this negative 1 to the other side, I would get 1 positive x over x, positive 1 less than or equal to 0. And this would be, if I were to take x to be the LCM, I would get 1 positive 2x less than or equal to 0. Right? On the other side, this is going to be, and I want to move this 1 to the other side. This is going to be 1 positive x over x negative 1 greater than or equal to 0. If I were to take the LCM, I would get 1 positive x negative x divided by x greater than or equal to 0. Positive x negative x gets cancelled, giving me 1 over x greater than or equal to 0, which means x is strictly greater than 0. Now over here, now clearly you can see that the points where this quantity will be less than or equal to 0 would be from negative 1 over 2, and x cannot take the value 0. This point is 0, x cannot. So this is closed and this is open. So only in this particular segment this inequality will hold good, right? So this is found out, and this is also found out. X is strictly greater than 0 means we have collection of all points between 0, infinity. Both of them are open. So we will have to unite these two intervals. So this is actually negative 1 over 2, 0. This is open, this is closed. So therefore the solution is going to be closed negative 1 over 2, 0 union 0, infinity. So let us check it out. Which of these choices, if you have to check this out, minus 1 over 2, 0, 0 is not included, 0 is not included, and we go all the way up onto infinity. So of all these choices, D is the right choice. Minus 1 over 2 closed to infinity and 0 is taken out, right? So this is the right solution. Students, now we will talk about decreasing functions. Now in inverse trigonometric functions, there are 3 main decreasing functions which we can focus on. Foremost, cos inverse of x. Number 2, cot inverse of x. Number 3, cosecant inverse of x. So cos inverse of x, cot inverse of x, cosecant inverse of x. Now whenever you are multiplying an inequality with one of these, the inequality will get reversed. Say for example, you got 3 is greater than 2, and that you are multiplying this inequality by cot inverse of x. Say for example, you are applying cot inverse. So this is going to be cot inverse of 3. I'm not placing the inequality. Let me just place cot inverse of 2 on the other end. So now we started with this 3 greater than 2. Now when we reach for this, the inequality will get reversed. So instead of saying 3 greater than 2, now it's going to be cot inverse of 3 lesser than cot inverse of 2. Now if you were to find the value of cot inverse, this is going to be 0.322, and cot inverse of 2 is going to be 0.464. You can clearly see that our concept of reversing the inequality is holding good here, holds good, because cot inverse of 3 is 0.322 and the cot inverse of 2 is 0.464, right? So that's exactly what we've been talking about. So have that in mind. Now if in case you are removing the decreasing function, so this is when you add, when I say add, it means the product, right? So it also includes, in case of systems of equations, if you are adding a decreasing function, that is also taken into consideration. So this is when you add a decreasing function, right? So this exactly happens. On the other end, if you remove the decreasing function, if you remove, say for example you are removing cot inverse from this inequality, so what happens? It means this inequality has to be reversed. So 3 is greater than 2. You follow me? When you bring the decreasing function, the direction of the inequality changes. Similarly, when you remove the decreasing function, again the direction of the inequality changes. So this is a beautiful concept and it is worth taking note of. So next is we will be dealing with problems connected with decreasing functions. Let's do this question, students. We are expected to find the domain of the function f of x is equal to square root of 3 times cos inverse of 4x negative pi. Now there are two parts in this inequality. Now the first part is this entire quantity should be greater than or equal to 0, right? So that's exactly what I'm going to do. So 3 times of cos inverse of 4x negative pi should be greater than or equal to 0 for the function to exist. Now the second part, this is part 2, is this value x. Now we know that if f of x is equal to cos inverse of x, then the domain is lying between -1 and +1 for cos inverse of x. But instead of x I've got 4x. So in this case it's going to be -1 less than or equal to 4x less than or equal to +1. This is what we've got. Now let me handle this first. So if I were to divide by 4, this is going to be -1 over 4 less than or equal to x less than or equal to 1 over 4. So this is already completed. Now let me head to the part 1. Now what I wish to do is I would like to move this pi to the other side. So it's going to be 3 times of cos inverse of 4x greater than or equal to pi. Now this 3 can be brought down, so there's going to be cos inverse of 4x greater than or equal to pi over 3. Now I need to evaluate this pi over 3. So what I wish to do is I would like to multiply by cos on both sides. So this is going to be cos. Now I already mentioned to you, when you perform this, the inequality has to be flipped, right? So the new inequality is going to be cos inverse of 4x. This inequality gets reversed, so it's going to be less than or equal to cos of pi over 3, right? Now this is 60. Cos 60 is less than or equal to 1 over 2. Cos and cos inverse gets cancelled, giving me 4x. So x is less than or equal to 1 over 8. So this is the solution. For this inequality, right? Now what we have to do is we have to club these two together. So the solution is going to be x less than or equal to 1 over 8. In this case it's going to be between -1 over 4 and 1 over 4. So we will have to stretch all the way to 1 over 8. So closed interval -1 over 4, that's the smallest value, and then it goes all the way up unto 1 over 8. So this is the solution for this particular question. Now what happens is they have given us choices. So choice number A, let me write down those choices. Choice A is -1 over 4, 1 over 8. Choice B is 1 over 8, 1. Choice C is 1 over 8, 1 over 4. And choice D is -1, 1 over 8. Right? So clearly we can see that -1 over 4, 1 over 8. Choice A is the right answer for this question. Students, we have been given another beautiful question. The question is as follows. We are expected to find all x satisfying the inequality cot inverse of x raised to the power of 2 followed by negative 7 cot inverse of x positive 10 greater than 10, it's greater than 0. Okay, so we are being given a list of choices, and the question continues. Lie in the interval. So we have following choices. A is negative infinity, cot 5 union cot 4 comma cot 2. B is cot 2 comma infinity, and C is infinity comma cot 5 union cot 2 comma infinity, and D is cot 5 comma cot 4, right? Now clearly you can see from the choices you cannot pick up a choice or pick out a choice by guesswork. That is not going to be working out. We need to really solve it. So foremost, let me just give you the solution, how exactly to get this. Now consider cot inverse of x raised to the power of 2 negative 7 times cot inverse of x positive 10 greater than 0. I'm going to take, let t be equal to cot inverse of x. Substituting this, if you were to take this as 1, therefore 1 can be rewritten as t squared negative 7 times t positive 10. This is greater than 0. Now this is a quadratic in t, and it can be factored as t negative 5 times t negative 2 greater than 0. So from here I can write, there are two values possible, right? So 2 and 5. So either t is less than 2 or t is greater than 5. But t is cot inverse of x, right? So that would mean I got cot inverse of x less than 2 or cot inverse of x greater than 5. Now if you were to see the graph of cot inverse of x, you will realize that the graph is actually contained with pi being the bound. So let me just show you the graph. So this is pi. It starts from 0, goes up to pi. If I were to draw the graph is going to be like this. Okay, and the value of pi is approximately 3.14. But over here it says cot inverse of x is greater than 5. So this is actually not possible. Not possible. And so we have to reject this value. So just drop this. Right? This is dropped. So we are left with cot inverse of x less than 2. Right? If I were to move cot inverse to the other side, I would get x is, in fact, if I were to apply cot on both sides, I have clearly mentioned to you that we are dealing with a decreasing function, right? So the inequality will get reversed. So this is going to be cot of cot inverse of x, and this is going to be cot 2. So the inequality will get reversed like this, and cot inverse will get neutralized, giving me x greater than cot 2. So all values of x that is greater than cot 2. So the solution for this is going to be cot 2 comma infinity. So this is going to be the solution, right? So let's go back to the choices and see which of these is matching. Clearly you can see B, cot 2 comma infinity. So this is the right choice for this particular question. We got a beautiful question, and the question is as follows. If alpha is equal to 3 times sine inverse of 6 over 11 and beta is equal to 3 times cos inverse of 4 over 9, where the inverse trigonometric functions take only the principal values, right? We have already studied about principal values. Then the correct choices are, so the question can be the correct choices, or what I would want to say is it can either be a singular tone or a plural tone, right? So depending upon what the choices are. In other words, a question might have 3 solutions or 4 solutions or 5 solutions, right? So we should not restrict our thought process to just locating one solution. So that is exactly what the question wants. The question wants you to find out all possible solutions. So I am just placing here correct choices are. So it can even exist just one solution. So in that case, then the correct choice is, right? So you can rephrase it as you wish depending upon the availability. So I would like to suggest that you keep your mind broad and expect different probabilities of results. So having mentioned that, we got the choice. A, is it cos beta greater than 0? B, is it sin beta less than 0? C, is it cos of alpha positive beta greater than 0? D, is it cos alpha less than 0? So we have 4 choices. Now among these 4 choices, you might find only one choice that is suitable for this question, or 2 choices suitable for this question, or 3, or even all the 4. So that is exactly what I wish to say. Now we have been given alpha is equal to 3 times sine inverse of 6 over 11. Now you got 6 divided by 11, but I have no clue what is 6 over 11. Sine inverse of 6 over 11, I am totally not aware of a value like 6 over 11, a standard value. Of course, we can always adopt the use of calculator and extract the value of sine inverse of 6 over 11. But as of now, out of my mind, I wouldn't be able to tell the value of sine inverse of 6 over 11. So in that case, what I wish to do is I would like to make a comparison. Now clearly 6 over 11 is greater than 6 over 12, right? This we know. So this is one type of technique in mathematics. Whenever you are given certain challenging questions, you can always associate the question to a known question whose solutions are well aware to your knowledge, and then boil the solution down to the requirement. So that is exactly what I'm doing. I'm just taking 6 over 11 and I'm comparing it with 6 over 12. Of course, I know what a 6 over 12 is. So I am taking sine inverse on both sides. So this is going to be sine inverse of 6 over 11. This is going to be greater than sine inverse of 6 over 12, right? Now sine inverse of 6 over 12 is nothing but sine inverse of 1 over 2. This is a standard value, we all know. Now this is as such 6 over 11. So this is the next step. Now I need to have a 3 here. You can clearly see there is a 3 that's been multiplied. So let us multiply 3 on the left side. 3 times sine inverse of 6 over 11. And this is greater than 3 times sine inverse of 1 over 2. So that's fine. Now this is given to be as alpha. If you were to check the question, it says alpha is equal to. So let me just take alpha. It's given. So alpha is greater than. Now 3 times sine inverse of 1 over 2. That's nothing but 60 degrees. 30 degrees, not 60. Sine 30 is 1 over 2, right? So that would mean the value of this quantity, angle, is going to be pi over 6, right? Sine pi over 6 is going to be 1 over 2. So this is well known. So I would like to take that and place it here. So 3 times of sine inverse of 1 over 2 is pi divided by 6. So this implies alpha is greater than 3 divided 6 2 times. So pi over 2. Now when you see something like this, alpha is greater than pi over 2, the understanding that we should draw here is to first draw the quadrants. So this is 0, this is 90, this is 180, this is 270, and this is 360. Now 90 is over here. Alpha is greater than pi over 2 means it should only be in the second quadrant. So whenever we talk about a quantity greater than an angle, you have to always understand that it would be slightly larger, right? It won't be so large that it will skip to the next quadrant. From quadrant 2 it won't go to quadrant 3. It will be slightly larger. So in this case alpha is greater than 90 degree means it would be present in quadrant 2. That is the understanding we should draw. Now in quadrant 2, if we were to represent this by CAST, only sine is positive. So having mentioned that sine is positive, so that would mean cosine is negative, right? So if I were to take cos of alpha would be less than 0. So let us go to the choices and examine it. So if you were to see here, this is beta, we don't need this. Alpha plus beta, we are still yet to find beta. So this is out of the question. Now you got cos alpha less than 0. This is exactly what I was just mentioning here. Cos alpha less than 0. So cos is negative. So this is a exact right choice. I shouldn't say use the word exact. This is a correct choice. But now let us go up and obtain the value for beta. Now what is beta? Beta says 4 over 9. So I can very well do that working over here. So clearly, as I mentioned to you in the earlier case, just associate 4 over 9 to a value that you already know. Clearly I know 4 over 9 is less than 4 over 8. 4 over 8 is nothing but 1 over 2. Now this has got cos. So I'm attacking by cos. Now cos is a decreasing function. So whenever you are taking cos inverse of a value, the inequality gets reversed. You should understand cos inverse is a decreasing function, whereas we not reverse the inequality for sine. The reason being sine inverse is an increasing function. So since cos inverse is a decreasing function, the inequality will get reversed and we can write it like this. Cos inverse of 4 over 8 is nothing but 1 over 2. So that's fine. Now I wish to multiply by 3 both sides. So there's going to be 3 times cos inverse of 4 over 9. This is greater than 3 times cos inverse of 1 over 2. This is what we have got. So now what I wish to do is I would like to replace 3 times cos inverse of 4 over 9 by this quantity beta, right? That's the exact representation that is being given in the question. So let us use the data from the question. So we now have beta is greater than 3 times. Now cos inverse of 1 over 2, that's going to be cos 60, right? We know that cos 60 degree is equal to 1 over 2. Now how do I represent cos 60 degree? Cos 60 degree is nothing but pi over 3, right? Cos pi over 3 is 1 over 2. So this is going to be pi over 3, right? So what happens here? 3 and 3 can be cancelled. So beta is greater than pi. Now beta is greater than pi. Let's go to the quadrant representation. So this is 180 degree. So this would fall in third quadrant. Beta greater than pi. So only tan is positive. So let's go back to the choices. Surely this cannot happen, right? They are saying cos beta is greater than 0. This is not possible. Sin beta is less than 0. Yes, sin is negative here. That's fine. So I've got B, I've got D. Now we need to check for alpha plus beta. Now this is the check for alpha plus beta. So what is alpha? Alpha is actually greater than pi over 2. So let me just write that down. Alpha positive beta. Therefore alpha plus positive beta is greater than pi over 2 positive beta is greater than pi. So place that. So what is this? This is equal to 2 pi plus pi. So this is going to be 3 pi over 2. So this would mean alpha positive beta is greater than 3 pi over 2. Now what is 3 pi over 2? That's nothing but 270 degrees. So alpha positive beta is 270 degree, means it will skip or it will just move to the fourth quadrant. In fourth quadrant, cosine is positive and its reciprocal is positive, right? Cos is positive along with its reciprocals. So let us go and check over here. So clearly you see this is exactly what they have given. Cos of alpha positive beta is greater than 0. So this is perfectly correct. So as I mentioned to you, you should have ticked if you were to encounter a question of this fashion in your examination, either in competitive examinations or examination for some scholarships or for some master's degree program, you should have selected B, C, D as the right choice. It doesn't matter if you were to select the C and then leave B and D off, you wouldn't get the score. So you have to select B, C, D. So this is the right choice, B, C, D, right? So have that in mind. So having mentioned that, let us move on to the next question. Students, we are given another beautiful question. The question is as follows. If cos inverse of x added with cos inverse of y added with cos inverse of z is equal to 3 pi, then we are expected to find the value of x raised to the power of 2024 positive y raised to the power of 2024 positive z raised to the power of 2024 positive 6 divided by x raised to the power of 2023 positive y raised to the power of 2023 positive z raised to the power of 2023. So we have the following choices being given. Choice A is 0, B is 1, C is -1, and D is 2. So these are the choices we have been given. Now let us consider the question. Consider cos inverse of x positive, cos inverse of y positive, cos inverse of z is equal to 3 times pi. Now I would like to ask you, when is this possible? Left hand side should be equal to right hand side. When can this occur? Now clearly you can see that this is only possible if cos inverse of x becomes equal to pi along with cos inverse of y becomes equal to pi along with cos inverse of z being equal to pi. This is the only possibility that is available for us to make the left hand side equal to right hand side. There is no other way that left hand side would be equal to right hand side apart from these values that cos inverse of the value x, y and z can take. So having mentioned that, so I have made this point clear to you. So if cos inverse of x is equal to pi, then clearly I can write here as x is equal to cos pi, right? And also over here I can write y is equal to cos pi and z is equal to cos pi. But what is cos pi? Cos pi is -1. So you got x is equal to -1, y is equal to -1 and z is equal to -1. So I've got the value for x, value for y and value for z. Now let me take this as 2. So therefore 2 can be rewritten as x raised to the power of 2024. So negative 1 raised to the power of 2024. Why? Because x is found to be equal to negative 1, followed by negative 1 raised to the power of 2024. Because y is raised to the power of 2024, followed by negative 1 raised to the power of 2024, positive 6 divided by negative 1 raised to the power of 2023, positive negative 1 raised to the power of 2023, positive negative 1 raised to the power of 2023. Now this is what? Odd quantity, odd number raised to the power of an even quantity. Right? You got negative 1 raised to the power of 2. What are you going to get? You're going to get a positive 1. Right? That is exactly what you have to place here. So this is going to be equal to positive 1, positive 1, positive 1, positive 6 divided by, this is a negative value, a negative quantity raised to the power of odd power. So you got negative 1 raised to the power of 3. What do you get? You get negative 1. So that's exactly what you need to place here. So negative 1 followed by addition of negative 1 followed by addition of negative 1. So what is this equal to? 1 added with 1 added with 1 would give you 3, followed by positive 6 divided by negative 1 added with negative 1 followed by negative 1 gives you negative 3. 3 divides 6 2 times. So this is negative sign. So this is equal to negative 3 followed by a negative 2. So what is this? 3 negative 2 will give you 1. So this is the solution, and let's go to the choices. Now clearly you can see the right choice is already there waiting for us to be selected. So that's the end of the solution, students. So this is a nice problem, and we'll move on to the next question. Students, we have another beautiful question. The question is as follows: find the number of real roots for the equation tan inverse of square root of x times x positive 1 positive sine inverse of root of x squared positive x positive 1 is equal to pi over 4. Now we have been given choices. A is it 1, B is it 2, C is it 4, D is it 0. Now foremost, to get the solution we must know where the function is defined. Right? In other words, we are looking for the domain of the function. Now clearly tan inverse of root of x times x positive 1 is defined for all values for which x times x positive 1 is greater than or equal to 0. So this is necessary. If x times x positive 1 is greater than or equal to 0, then only tan inverse of square root of this quantity is going to be existing, right? Because it cannot fall short of 0. That's the smallest value that is allowed so that this function is existing. So this is one side. We got the other side. Now we know that the domain for sin x lies between negative 1 and positive 1, right? But in this case we are looking at root of x squared positive x positive 1. So that would mean if I were to place negative 1 less than or equal to root of x squared positive x positive 1 less than or equal to 1, there is a small adjustment we need to do, because clearly negative 1 cannot be an outcome for this. So the minimum value that root of x squared positive x positive 1 will produce will be 0. So we will have to rewrite this as 0 greater than or equal to square root of x squared positive x positive 1 less than or equal to 1. So this is what is the permitted domain for this quantity, sine inverse of root of x squared positive x positive 1. So we got two sides, right? So now what I would do is I would try to simplify and extract the value for x here. Now if I were to take root of x squared positive x positive 1 is less than equal to 1 and square both sides, I would arrive at an inequality of this fashion. Now clearly I can get rid of this 1 on either side, and this would give me x squared positive x less than equal to 0, right? So this is almost done. So let us move on to the other inequality. Now distributing x would give us x squared positive x greater than equal to 0. So this is what I've got for this side. Now I've got an inequality here and I've got an inequality here. Now these two inequalities together have to be satisfied for this entire function to exist. So when would that be possible? On one side we got x squared positive x is greater than equal to 0. On the other side we got x squared positive x is less than equal to 0. Now to satisfy these two inequality would mean that there is exactly one particular point for which x squared positive x will be greater than equal to 0 and x squared positive x will be less than equal to 0, and that point would be x squared positive x equal to 0. Only at this particular point this inequality and this inequality will hold good. So having got that, let me just write it as x of x positive 1 is equal to 0. Clearly from here I write x is equal to 0, and then from here I write x is equal to negative 1. So those two values are obtained. Now what we need to do, we need to take this value and substitute it in this left side of this entire equation and find out if left hand side is equal to right hand side. So that is what we need to do. So let us just take x is equal to 0. Let me use this side of this space. X is equal to 0 and I substitute it here. 0, 0, positive 1. So this is going to be 0. So tan inverse of 0 is going to give me 0. And 0, 0 and sine inverse of root 1, that is going to be sine inverse of 1. Let me write that down. Sine inverse of 1. And that should be equal to pi over 4. Now sine inverse of 1 is what? It's pi over 2. So we have something like this. Pi over 2 being equal to pi over 4. Is it possible? No, it's not possible. Right? Pi over 2 cannot be equal to pi over 4. Not possible. Right? We cannot even dream of such a situation. Right? That is the best way to state. So x is equal to 0 has to be dropped. It doesn't serve our purpose. Now let me take x is equal to negative 1. So this is the case 1. So probably case 2. Let me just go to case 2. X is equal to negative 1. So if we were to substitute x is equal to negative 1, this is going to become 0. So tan inverse of 0 will be 0. X is equal to negative 1, positive 1, they get cancelled. Negative 1. Again I am getting sine inverse of 1, which has to be equal to pi over 4. Sine inverse of 1 produces pi over 2. Again I need to have a justifiable statement here, because this is basically giving us a contradiction, pi over 2 being equal to pi over 4. So again this is not possible, and so x is equal to negative 1 should also be dropped. So what is the understanding? We are unable to find values of x such that the left hand side is equal to right hand side. So that would mean we are not able to find any real root at all. So ultimately the choice of selection should be D. So this is a beautiful question, students. I hope you enjoyed it. Let's move on to the next one. Students, now it's time for us to understand the properties of inverse trigonometric functions. Okay, so let's get it started. First one, sine inverse of negative x is going to be equal to negative sine inverse of x. That's the first one. Now the second one is tan inverse of negative x is equal to negative tan inverse of x. And the third one, let me write this down here. Cosecant inverse of negative x is equal to negative cosecant inverse of x. Okay. Now you would remember, if f of negative x is equal to negative f of x, then we call f of x is an odd function. Right? So what is the meaning of this? So this means sine inverse of x, tan inverse of x, and cosecant inverse of x, they are all odd functions. So let's go on to the next set. Fourth one, cos inverse of negative x is equal to pi negative cos inverse of x. Very important. Number 5, cot inverse of negative x is equal to pi negative cot inverse of x. Number 6, secant inverse of negative x is equal to pi negative of secant inverse of x. Right? So make sure to write these in the corner of your mind and move on, students. Now we got the second set of properties too. So they are as follows. Let me write it as 7. 7. You have a trigonometric quantity sine, and then inverse trigonometric quantity sine inverse of x. When sine attacks sine inverse of x, outcome will be x, such that x lies between negative 1 less than equal to x less than equal to 1. Number 8, cos inverse of x will be equal to x, such that x lies between negative 1 and positive 1. Then number 9, tan inverse of x is equal to x, such that x is element of real number. We already know this. Number 10, cot inverse of x is equal to x with x element of r. Then we got number 11, cosecant inverse of x is equal to x, for which modulus of x is greater than or equal to 1. So the understanding for this is nothing but negative infinity followed by negative 1 union positive 1 comma infinity. So in other words, x is an element of this interval. So that is for cosec times of cosecant inverse of x. Now we got number 12. I'll write it down here. This is secant inverse of x is equal to x, such that modulus of x is greater than or equal to 1. Okay, so that is the set for property 2. Now the next one is going to be property number 3. So here we actually have sine of sine inverse. So in property number 3, that's 13, is going to be, instead of having sine, we are going to have sine inverse of sine x. The outcome is also going to be the same x, but the function is actually defined for x contained in negative pi over 2 comma pi over 2. This is critical. Right, here it is negative 1 less than or equal to x less than or equal to 1. In this case it's negative pi over 2 comma pi over 2. So 14, this is going to be cos inverse of cos x, which will also be giving us x, and in this case x is contained in 0, pi. So we got cos, we got sine, now it's going to be tan. So tan inverse of x will be equal to x, and in this case x is contained in the open interval pi over 2, pi over 2. So after this we need to go on to cosecant. So 16, cosecant inverse of x will be equal to x. In this case x is contained in negative pi over 2, pi over 2, taking 0 away, right? So in this case it's completely closed, in this case it's open, in this case it is closed with 0 being taken out. So we have already seen something similar to this in the earlier lesson. So this has a relationship with this, and subsequently this has a relationship with this. So I'm just showing you some technique to remember the x interval. So now coming to cos inverse have to be clubbed with cot. So this is number 17. So I've got cot inverse of cot x will also give me x, but apparently in this case this is closed, right? So x is going to be contained in open 0, pi. And then 18th one is going to be secant. So secant inverse of secant x will give me x, but with the x value being contained in 0, pi minus pi over 2. So we take away that value pi over 2. So this is connected with this. This is closed, this is open, and subsequently it is connected to the final one, secant inverse of secant x, right? So this is some techniques to remember the x values interval. Now let's move on to property number 4. The first one is sine inverse of x added with cos inverse of x will give us pi over 2, with x lying between negative 1 and positive 1. Number 2 is tan inverse of x added with cot inverse of x will give us pi over 2, with x element of real numbers. Property 3 is cosecant inverse of x added with secant inverse of x will give us pi over 2, with modulus of x greater than equal to 1. Students, we are given a nice question. So the question is as follows: if sine inverse of x squared negative x to the power of 4 divided by 3 positive x to the power of 6 over 9 etc. added with cos inverse of x to the power of 4 negative x raised to the power of 8 divided by 3 positive x raised to the power of 12 divided by 9 etc. is equal to pi over 2, such that 0 less than equal to modulus of x less than equal to root 3, strictly less than root 3, then the number of values of x is equal to, so we are given this equation, this added with this is equal to pi over 2, and the interval for modulus of x is given. Then we are expected to find all of those x's for which this equation holds good. And the number of such x's have to be found, as I mentioned to you, and the choices have to be placed there, right? Or I should say the choices have to be selected accordingly. So let me place those choices. So we have been given A to be as 1 and B is 2, C is 3 and D is 4. So let's start off. Now what I would like to do is I would like to use this particular property which we have seen. Now clearly I would like to draw your concentration and your focus to this particular property. Sine inverse of x, positive cos inverse of x is equal to pi over 2. Over here we have this expression and then this expression. Now sine inverse of this quantity, positive cos inverse of this quantity will be equal to pi over 2 only if these two quantities are equal. How do I know? According to the property. So this means this expression, right, let me just place a box there, should be equal to this expression. Now how am I going to get the expressions? So I would have to use the concept of geometric series. Now clearly this is a geometric series where the formula is a over 1 negative r. So we would use a over 1 negative r. A is the first term, so I can see that a's value for the first series is x squared and the common ratio r is negative x squared over 3. So this is for the first series. And similarly for the next one, a over 1 negative r, the a term is x to the power of 4, that's the first term, and r is negative x to the power of 4 divided by 3. So if I were to substitute these values, for the first quantity I would get x squared divided by 1 negative of negative x to the power of 3 over, x to the power of 2 over 3 with a negative sign. So this can be simplified and this has to be equal to the second quantity, which is x to the power of 4 divided by 1 negative of negative x to the power of 4 divided by 3. So if I were to simplify this, I would get x squared divided by 3 times, this is going to be positive x squared divided by 3, which can be flipped and rewritten as 3 times x squared divided by x squared positive 3. This has to be equal to, if I were to rewrite this, this is going to be 3 times x to the power of 4 divided by 3 positive x to the power of 4, right? So if I were to equate them, this is going to be 3x squared divided by x squared positive 3 is equal to 3x to the power of 4 divided by x to the power of 4 positive 3. Now you can cancel x squared, but if you're cancelling x squared, you will have to take x squared to be equal to 0. Now let me just simplify this and write this down here. So you have 3 times x squared times x to the power of 4 positive 3 is equal to 3 times x to the power of 4 times x squared positive 3. Now clearly x squared can be cancelled, 3 can be cancelled. So this is going to give me x to the power of 4 positive 3 is equal to x squared of x squared positive 3. This is what I have got. Now as I mentioned to you, I have cancelled x squared, so on the corner I will have to take x squared is equal to 0. So that is one system. Now we will have to solve this. So let me simplify this. This is going to be x to the power of 4 positive 3 is equal to x to the power of 4 positive 3 times x squared. Now this and this gets cancelled. So I now have 3 times x squared negative 3 is equal to 0. From here I can write 3 of x squared minus 1 is equal to 0. So this would mean x squared is equal to 1 and x is equal to positive 1, x is equal to negative 1. So over here x is equal to 0 is one value, and then next value x is equal to negative 1, and then x is equal to positive 1. So 3 values we have secured. So the choice is C. If you were to go back to the choices and check it out, C is the one which gives us 3. So there are 3 such values of x for which the given equation holds good. It's a beautiful question. The question is as follows. If sine inverse of x raised to the power of 2 negative cos inverse of x raised to the power of 2 is equal to some a, and that x lies between 0 and 1, with a not being equal to 0, then we are expected to find the value of 2 times x squared negative 1. And we have been given with choices. A is that cos 4a over pi, b is that sine 2a over pi, c is that cos 2a over pi, and d is that sine 4a over pi. So it's a lovely question. Now foremost, let me consider sine inverse of x raised to the power of 2 negative cos inverse of x raised to the power of 2 is equal to a. Now we know a formula, a squared negative b squared is equal to a negative b times a positive b. So by this formula I can rewrite this as sine inverse of x negative cos inverse of x times sine inverse of x positive cos inverse of x, which is equal to a. But we know that sine inverse of x positive cos inverse of x is equal to pi over 2. I substitute that, I get sine inverse of x negative cos inverse of x times pi over 2 is equal to a. I push this 2 and pi down. So this is going to be 2a over pi. This is sine inverse of x negative cos inverse of x. Now since sine inverse of x positive cos inverse of x is equal to pi over 2, I can clearly write sine inverse of x to be equal to pi over 2 negative cos inverse of x. So I take this and I substitute here. So this is going to be pi over 2 negative cos inverse of x negative cos inverse of x is equal to 2a over pi. Now this is going to be equal to pi over 2 negative cos inverse of x added with cos inverse of x would give me negative 2 times cos inverse of x is equal to 2a over pi. Let me move this to the other end. So I get negative 2 times cos inverse of x is equal to 2a over pi negative pi over 2. And if I were to push this 2 down, in fact there's a negative sign, so I would have to get rid of the negative sign. So I can get rid of the negative sign as follows. So 2 times cos inverse of x. If I were to push this negative sign out and rearrange this, this is going to be as follows. So negative of pi over 2 positive, no, it's negative 2 times a divided by pi, right? And you have a negative sign here. So clearly what happens, this negative gets cancelled. So you have cos inverse of x being equal to pi over 2 negative 2a over pi divided by 2. And if you were to flip this up, this is 2 over 1, right? So this is going to be 1 over 2 times pi over 2 negative 2a over pi, which is nothing but pi over 4 negative a over pi, which is my cos inverse of x. So if I want to find x, so taking cos on both sides, this is going to give me x is equal to cos of pi over 4 negative a over pi. Right, this is for x. But we are asked to find the value of 2 times x squared negative 1. So therefore 2 times x squared negative 1 is equal to 2 times of my cos value is, in fact my x value is cos of pi over 4 negative a over pi. This is squared, so this is going to be cos squared followed by negative 1. Now we know that 2 times cos squared theta negative 1 is cos 2 theta, right, formula. So this can be rewritten as 2 times x squared negative 1 is equal to cos of 2 times of theta is this pi over 4 negative a over pi, right. If I push this 2 inside, this is going to give me cos of pi over 2 negative 2a over pi. Now this is nothing but cos of 90 negative theta. What is that? Sin theta. So this is going to be equal to sin 2a pi, right? So do we have sin 2a pi? It's right over here, sin 2a over pi. This is a beautiful question. Let me just write that question down. If sin inverse of x over a is equal to cos inverse of x over b is equal to tan inverse of y over c, with this x lying between 0 and 1, we are asked to find cos of pi c over a positive b, right? This is required. So the choices, let me write down the choices. A is it 1 negative y squared over 2y, b is it 1 negative y squared over 1 positive y squared, c is it 1 negative y squared, and d is it 1 negative y squared over y times the root of y. So this is an interesting question. Now we have studied a law in ratio and propositions. Suppose you got a over b is equal to c over d is equal to e over f, then this means a positive c divided by b positive d is equal to e over f. Let me give you an illustration. 1 over 2 is equal to, say, 2 over 4 is equal to 3 over 6, then clearly 1 positive 2 divided by 2 positive 4 will be equal to 3 over 6. So I would be using the same property, right? So let me just box this off. Now using this same property, I can rewrite the given question as sin inverse of x positive cos inverse of x divided by a positive b is equal to tan inverse of y divided by c. Fine. But we know that sin inverse of x positive cos inverse of x is equal to pi over 2, right? So take this and substitute it here. So this would mean pi over 2 is nothing but pi over 2 times of a positive b is equal to tan inverse of y divided by c. So let me push this c to that side so that I can get pi c. So this would mean I have pi c divided by, I don't want this 2 here, let me push the 2 the other side and just retain a positive b. So this is going to be 2 times of tan inverse of y. Now we need cos, so let me use the space here. So I'm applying cos, so it's going to be cos of pi c divided by a positive b is equal to cos of 2 times of tan inverse of y. Now let me take tan inverse of y is equal to theta. So this means y is equal to tan theta. So Therefore, I can write cos of 2 times of tan inverse of y as cos of 2 theta. Now, what is cos of 2 theta? Which is, this is equal to 1 minus tan square theta divided by 1 positive tan square theta. But what is tan theta? Tan theta is y, so it's going to be 1 negative y squared divided by 1 positive y squared, which is nothing but our cos of pi c over a positive b, right? But where is this? Let us go back to the choice and see. You see that? 1 negative y squared divided by 1 positive y squared. That's the solution for this question.